You noticed it first in some small and ordinary way. Maybe you glanced at a calendar and could not account for where 4 months had gone. Maybe someone mentioned an event you remembered clearly, an event that felt recent, and then told you it had happened 9 years ago. Perhaps it was a photograph. Perhaps it was a child who had grown a foot taller since the last time you looked properly. Whatever the trigger was, the sensation underneath it was the same, and almost everyone alive today reports some version of it. Time is moving faster than it used to. Not slightly faster. Not slightly enough to dismiss as mood or fatigue. Faster in a manner that feels structural, as though something beneath the surface of the world has quietly changed its rate and forgotten to tell anyone. You have probably said this out loud at some point. You have probably heard it said back to you, at a table, in a car, in a hallway, at work, by someone who then laughed and shrugged and changed the subject because there is nothing to be done about it and no obvious way to continue the conversation. That is where it usually ends. A shared observation, a shrug, and back to whatever was happening before. But it does not end there in every culture, and it did not end there in the oldest written civilization we have any record of. Because roughly 4,000 years before anyone reading this was born, in the flat river country between the Tigris and the Euphrates, scribes were pressing wedge-shaped marks into wet clay, and among the things they recorded were numbers. Enormous numbers. Numbers attached to the reigns of kings, to the movements of planets, to the length of the day, to the structure of the year, and to a claim so strange that most modern readers scroll past it without pausing, because it does not parse as history. It parses as error. The claim is this: that the gods lived on one clock and men live on another, that the two clocks are not merely different in scale but different in nature, and that the distance between them is not fixed. That last part is the part nobody talks about. We are going to talk about it. This is not a story about aliens landing in a field. It is not a story that requires you to believe anything at all. It is a story about a real civilization, real objects that sit in real museums with real accession numbers, real mathematics that you personally use every single day without thinking about it, and a real, documented, measurable anomaly in the rotation of the planet you are standing on that began around the year 2020 and that professional timekeepers are, right now, arguing about how to handle. Those are the pieces. What you assemble from them is your business. Nobody is going to tell you what to think. But by the end of this, you will not be able to look at a clock the same way, and you will understand why the people who invented the clock were so frightened of what it was measuring. Start with the feeling itself, because the feeling is real, and the feeling is not new. Ask anyone over the age of 40, and you will get the same report with different decorations. The summers of childhood were enormous. A single afternoon could hold an entire expedition. A school year was a geological era. The stretch between one birthday and the next was so long that it functioned as a kind of horizon, a distance you could not see across. And then, at some point that nobody can identify precisely, the horizon collapsed. The years began arriving like train cars, coupled and fast, each one indistinguishable from the last. You blink and a decade has been spent. You start a project in what feels like spring, and finish it in what turns out to be the following autumn. The word people reach for is almost always the same word: accelerating. Notice that this is not a complaint about being busy. Busy is a different sensation entirely, and busy people frequently describe individual days as long. The acceleration is retrospective. It happens when you look back. The day was ordinary, the week was ordinary, and then you turn around and 6 years have gone missing, and no accounting can be given for them. Notice also that this is not a complaint about aging in the physical sense. It is reported by people in perfect health. People who are happy report it just as often, and just as uneasily. The unease has a particular quality, a low-grade alarm, as though a fire has started somewhere in the building and nobody can locate the smoke. And notice, finally, that it is reported nearly universally, across languages, across cultures, across income brackets, across continents. That universality is the first thing that makes it interesting. Universal human experiences tend to have causes. They tend not to be coincidences. Modern science has an answer to this, and it is a good answer. And we are going to spend a great deal of time on that answer later, because a story that only shows you one side is not a story, it is a sales pitch. The modern answer is elegant, testable, and supported by careful laboratory work. Hold that thought. Keep it in your pocket, take it out, and look at it whenever what follows starts to feel too tidy. Because the ancient answer exists too, and the ancient answer is older, stranger, and written down. To understand why anyone should care what a Bronze Age scribe thought about the rate of time, You have to understand who these people actually were, and almost everything you think you know about them is probably too small. The land was called Sumer, not a country in the way we use the word, a scatter of city-states across the southern floodplain of what is now Iraq, in the delta where the Tigris and the Euphrates run down toward the Persian Gulf. Uruk, Ur, Eridu, Lagash, Nippur, Kish, names that sound like sounds rather than places, because they are older than the habit of places having the kinds of names we expect. These cities were not villages. Uruk, at its height, somewhere around 3,100 years before the Common Era, held tens of thousands of people inside a wall that ran for something close to 6 miles. It was, by a wide margin, the largest human settlement that had ever existed at that point on the planet. There had never been anything like it. There was no precedent. Nobody had ever seen that many human beings in one place, because that many human beings had never been in one place. Consider what that actually means. Every problem that a city creates, these people encountered first. Sanitation, water rights, property disputes between strangers, the storage and distribution of grain across a population too large to know each other by face, debt, contracts, labor organized at a scale where trust cannot be personal, law. They did not inherit solutions to any of it. They invented the solutions, from nothing, under pressure, and most of the solutions they invented are still running. Chief among the inventions is the one you are reading right now. Writing. Not writing as decoration or as ritual, but writing as accounting, which is what writing actually was at the start. The earliest cuneiform tablets are not poetry, they are receipts. So many measures of barley, so many head of sheep, this much beer allotted to this many workers on this day. The romance of the origin of literature is that there is no romance in it. Somebody needed to remember how much grain went into a warehouse, and the human memory was not adequate, and so a reed was pressed into wet clay, and the shape of that mark meant grain, and civilization began as a way of not losing track. That detail matters more than it appears to. Writing was invented to solve a problem of time. Memory decays. Clay does not. The first act of literacy on this planet was an act of defiance against forgetting. Hold on to that as well. The medium was clay, and that accident of geology is why we know any of this. Egypt wrote on papyrus and papyrus rots. The Indus civilization wrote on something we have not recovered, but southern Mesopotamia had no stone worth quarrying, and very little timber. And what it had in unlimited supply was river mud. So they wrote on mud, and then, sometimes, buildings burned down, and fire does to clay what it does to pottery. It fires it. It makes it permanent. Every catastrophe in Mesopotamian history baked another library into immortality. We know about these people because their cities kept burning down and their archives kept surviving the fires. There are, by conservative estimate, somewhere north of 500,000 cuneiform tablets sitting in museum collections around the world at this moment. The British Museum alone holds something on the order of 130,000. And here is the fact that stops people cold when they first encounter it. A substantial portion of them have never been read, not lost, not destroyed, not hidden, cataloged, boxed, shelved, and simply never translated. Because the number of people on Earth who can read Sumerian fluently is small enough to fit comfortably into a single lecture hall, and the tablets outnumber the specialists by a ratio that borders on the absurd. There is a real and ongoing situation in which the oldest written thoughts of the human species are sitting in drawers, in the dark, unread, in the middle of London, because nobody has gotten around to them yet. Think about the odds embedded in that. Whatever the Sumerians knew, we have not finished finding out. Whatever they wrote down, we have not finished reading. Every so often, a specialist opens a box that has not been opened since the 1890s and finds something nobody expected. This happens with enough regularity that it is not news anymore inside the field. It is Tuesday. So when someone says the Sumerians said this or the Sumerians believe that, the honest response is a question. Which tablet? Where is it? Who translated it? When? And has anyone checked the translation since? Those questions are going to get asked repeatedly in what follows, because they are the difference between history and decoration. Now, the Sumerians and time. Here is where the ground begins to tilt, and it tilts using nothing but facts you can verify in an afternoon. Look at a clock, any clock. 60 seconds make a minute, 60 minutes make an hour. Look at a compass or a protractor. 360 degrees make a circle. Look at a calendar and notice that 12 months make a year, and that the ideal, schematic year underlying an enormous amount of ancient and modern administrative practice is 360 days, 12 months of 30, 60, 360, 12, 30. Now ask yourself why. because there is no natural reason for any of it. We count in tens. We have 10 fingers. Every intuition we possess about number is decimal, and has been since childhood, and the entire scientific apparatus of the modern world runs on base 10, meters, grams, liters, percentages. And yet the moment you touch time, or the moment you touch angle, the decimal system evaporates and something else takes over, something with a completely different logic, and nobody ever explains it to you, and you have never once questioned it, and you use it every single day of your life without noticing that it is there. That something else is sexagesimal, base 60, and it is Sumerian. Not Sumerian in the sense of inspired by, or descended from, or vaguely traceable to. Sumerian in the sense that these specific people, in these specific cities, in the 3rd millennium before the Common Era, built a positional number system on the base of 60, and used it and taught it to the Akkadians, who taught it to the Babylonians, who refined it into the most powerful mathematical instrument in the ancient world, and passed it to the Greeks, who used it for astronomy because nothing else was as good, and the Greeks passed it to the Islamic world, which preserved and extended it, and it came back into Europe, and it never left. It is still here. The system sits on your wrist and inside your phone. The division of your hour is a Bronze Age artifact that has been running continuously for something on the order of 4,000 years, and it is arguably the oldest continuously used piece of technology in the human world. Older than any building you can name that is still in use for its original purpose. No nation on Earth is as old. No religion currently practiced is as old. The alphabet itself came later. The Sumerian language itself died as a spoken tongue somewhere around 2,000 years before the Common Era. And their way of cutting up an hour outlived their language by 4 millennia and shows no sign of stopping. Why 60 though? This is where the standard explanation gets offered, and the standard explanation is genuinely good, so it deserves a fair hearing. 60 is what mathematicians call a highly composite number. It divides cleanly by 2, 3, 4, 5, 6, 10, 12, 15, 20, and 30. 10, our base, divides cleanly by 2 and 5, and that is the whole list. If you are running an economy where grain must be split among workers, where fields must be partitioned among heirs, where a debt must be divided into portions, and where you do not have decimal fractions because nobody has invented them yet, then a base that divides a dozen ways is not a curiosity. It is infrastructure. It is the difference between a clean answer and an argument. There is a second explanation, and it is charming, and it may even be right. Look at your hand. Ignore the thumb. The 4 remaining fingers have 3 bones each, 3 visible segments. 4 times 3 is 12. Use the thumb as a pointer, and you can count to 12 on one hand. Now use the 5 fingers of the other hand to count how many 12s you have completed. 5 times 12 is 60. A two-handed counting system with a natural ceiling of 60, requiring no equipment, portable, and obvious once you have seen it. Whether this is what actually happened is not something anyone can prove, but it is not a fantasy either. Finger counting systems of exactly this type are attested across the ancient Near East and survived into recent centuries in parts of the region. Both explanations are reasonable. Both are probably partly true. Neither of them is the interesting question. The interesting question is why a system built for dividing barley ended up governing the division of time and the division of the sky, and why, when every other domain of measurement in the modern world was converted to decimal during the great metric rationalizations of the 18th and 19th centuries, time refused, because it was tried. That is the part people do not know. During the French Revolution, in the same wave of rational reform that gave us the meter and the kilogram and the liter, France introduced decimal time. 10 hours in a day, 100 minutes in an hour, 100 seconds in a minute. Clocks were manufactured. Some of them survive and you can look at them. The decimal calendar came with it, 12 months of 30 days, 3 weeks of 10 days each, and 5 spare days at the end of the year. It failed. Completely. It lasted, officially, for about 17 months before being suspended, and the informal resistance had killed it long before that. People simply would not use it. The most aggressively rational government in European history, at the height of its power, with the guillotine standing in the public square as an argument, could not persuade the French population to abandon a system of hours invented by Bronze Age scribes in Iraq. Everything else went decimal. The meter conquered the world. The kilogram conquered the world. Time held. That is a genuinely peculiar fact, and it is not usually presented as one. It is usually presented as an amusing footnote about revolutionary excess. But turn it around. Something about the sexagesimal division of the day is so deeply embedded, so structurally load-bearing, that a civilization with absolute power and total commitment could not pry it loose. And the same thing happened, more quietly, everywhere else. Every metric nation on Earth uses 60-second minutes. Every one. There is no exception. The most thorough standardization project in human history swept the planet and detoured around the clock. Now, a careful person will say, correctly, that this is inertia and nothing more. Time is coordinated. Time is the one measurement where being different from your neighbor is not inconvenient but catastrophic. You can sell wheat in pounds to a man who buys in kilos with some arithmetic. You cannot hold a meeting with a man whose hour is a different length. The network effects on timekeeping are more powerful than on any other unit, so the clock is the hardest thing to change, and that fully explains the failure of decimal time without invoking anything mysterious at all. That is a good argument. Sit with it. It is probably right. And yet, the Sumerians did not stop at 60. 60 was the floor of the system, not the ceiling. Sexagesimal notation is positional, like ours, but each position is worth 60 times the one to its right instead of 10. So the units run 1, then 60, then 3600, then 216,000, and upward from there without limit. And each of those magnitudes had a name and a written sign. And here's the thing that turns the whole discussion. The names were not only numbers. 60 was Jess. 3600 was Sar, which is also written Shar. 216,000 was Shar-Gal, the Great Shar. And these signs did double duty. The sign that meant 3600 as a quantity of barley could also mean 3600 as a quantity of years. The number and the duration shared a body. 3600 years, 1 Shar. Write that down, because everything that follows in this account is going to circle back to it. 3600. It is the number at the center of the king list. The Anunnaki material turns on it as well. A certain 20th century author built an entire cosmology out of it, wrongly, in ways we will examine without mercy and without dismissing what remains underneath the wreckage. And it is, first and before all of that, simply the third position in the counting system of a people who used the same word for a heap of grain and a span of history. The Sumerians measured the day too, and the method they chose should give you pause. Their basic unit of time was the dana, sometimes rendered baru, and a dana was 1/12 of a day, which makes it 2 of our hours. 12 dana to the full day and night. Each dana divided into 30 gesh, and a gesh comes out to 4 of our minutes. So the day was sliced 12 ways, and then 30 ways. And 12 times 30 is 360, and there are 360 degrees in a circle, and the reason there are 360 degrees in a circle is that the Sumerians and their successors treated the passage of a day and the sweep of a circle as the same object measured twice. That is not a coincidence, and it is not mysticism. It is engineering. Time and angle were the same thing to them because time was measured by angle, by the movement of the sky across the fixed frame of the horizon. And so the units transferred, and they transferred so successfully that they are still transferred. And when a navigator on a ship in the middle of the Pacific in the year 2026 converts an hour angle into a longitude, he is performing an operation designed in Iraq before the pyramids were finished. The circle and the clock are the same instrument. The Sumerians knew that. We inherited the instrument and forgot the reason. And a shape that is a circle has one property that a line does not. It comes back around. Quick pause. And this is something new. For the first time since the 12 codes, there's a second document. It's called the 7 resets. Every time the world was erased, matched against the shrinking reigns of the king list and the checklist of signs for the 8th. 4 are already active. Linked below, QR code on screen. Back to the video. There is an object in Oxford, in the Ashmolean Museum, and it does not look like much. It is a piece of baked clay, roughly the size and shape of a thick forearm, 4-sided, tapering slightly, with a hole bored through the long axis so that it could be mounted on a spindle and turned. The surface is covered in small, dense cuneiform. It is chipped. It is the color of old bread. In photographs, it manages to look simultaneously precious and disappointing, the way most genuinely important artifacts do. It is cataloged as the Weld-Blundell Prism, and specialists refer to it as WB444. It was acquired for the museum by Herbert Weld Blundell in the early 20th century, and it comes out of Larsa, in southern Iraq, and it dates to somewhere around 1800 years before the Common Era. You can look it up. You can look at photographs of it right now. It is not a rumor, and it is not a controversy. It is a specific object in a specific case with a specific number, and it is the most complete surviving copy of a document that scholars call the Sumerian king list. What the king list does is simple to describe and impossible to accept. It lists the kings of Sumer in order, city by city, from the very beginning, and it tells you how long each one reigned. That is the entire structure. A name, a city, a number of years, and then the formula that the kingship was carried away to somewhere else, and then more names. It reads like a spreadsheet. It reads, honestly, like the driest thing ever committed to clay. And for the last third of it, roughly speaking, it lines up with independently verifiable history. Kings we have other evidence for. Reign lengths that make sense. 20 years. 36 years. 9 years. The ordinary arithmetic of human political life, then you read it from the top, and the arithmetic changes. The opening line of the document says that kingship descended from heaven, and that it descended first upon the city of Eridu. Eridu is real. It is in southern Iraq, it has been excavated, and there is a reasonable archaeological argument that it is among the oldest permanently settled cities on the planet, with occupation layers going back roughly 7,000 years. So the geography checks out, the chronology does not. The first king at Eridu is named Alulim. According to the list, Alulim ruled for 28,800 years. Not 28, 28,800. His successor at Eridu, Al-Algar, is credited with 36,000 years. Then the kingship moves to Bad Tibira, and Enmen-Luana rules for 43,200 years, and Enmen-Galana for 28,800, and a figure named Dumuzi, described as a shepherd, for 36,000. Larak follows. After Larak comes Sippar, where Enmen-Dur-Ana rules for 21,000 years, and then Shurapak, where Ubaratutu rules for 18,600. And then the list says something that changes its character entirely. It says that the flood swept over. Add the pre-flood rains together and you get, depending on which copy you are reading and how you handle the damaged sections, a figure in the neighborhood of 241,200 years. 8 kings, 5 cities, 250,000 years of continuous recorded monarchy, according to a document written by people who were otherwise scrupulous accountants, on a prism that also contains reign lengths of 18 and 24 and 36 for the kings closer to the writer's own time. That is the problem. That is the whole problem, in one object. The same scribe, in the same document, in the same hand, using the same notation, gives you both. Ordinary numbers for the recent past, impossible numbers for the deep past, and no editorial comment whatsoever, nothing in the margin, to say that these figures are symbolic. The tone never shifts. There is no warning of any kind, only the same flat administrative voice, listing 28,800 years, the same way it lists 24. The mainstream reading of this is well developed and it deserves respect, so here it is at full strength before anything else is said. The king list is not history. It is propaganda, and rather sophisticated propaganda at that. Its purpose is to establish that kingship is a single, unified institution, divine in origin, that passes from city to city but never divides. That claim is politically useful to whoever is currently holding the kingship, because it means their authority is the same authority that came down from heaven at Eridu, and it means rival cities do not have a competing legitimate claim, only a past turn or a future one. The list flattens what was almost certainly a messy scatter of contemporaneous, competing city-states into a tidy sequence, precisely because a sequence has only one occupant at a time. And the enormous numbers, on this reading, are doing exactly what enormous numbers do in every tradition. They are conveying antiquity, not duration. They are saying this is old beyond reckoning. Compare the ages in the 5th chapter of Genesis, where Methuselah reaches 969 and Adam reaches 930. The Yuga cycles of Hindu cosmology run into the millions. Egyptian tradition gives the reigns of the gods before the first human pharaoh in similar magnitudes. Every ancient culture that kept a king list did this. The deep past inflates. It is a literary convention, not a measurement. And reading it as a measurement is a category error of the same kind as reading a poem as a weather report. There is a further point, and it is a strong one. The numbers are not random. Nearly every pre-flood reign is a clean multiple of 3,600. 28,800 is 8 shar. 36,000 is 10 shar. 43,200 is 12 shar. 21,000 is not a clean shar multiple, but it sits neatly as 5 shar plus 3,000. And there are known variants of the list that adjust it. When your data is composed almost exclusively of round multiples of a single base unit, your data is not observation. Your data is construction. Real durations do not arrive in tidy multiples of 3600, any more than real rainfall arrives in tidy multiples of 100 millimeters. Some scholars have gone further and proposed that the figures are the residue of a numbering system that got misread. If the original notation used sexagesimal place values and a later copyist interpreted a positional mark as a multiplier, or if a unit that originally meant something smaller got promoted, then the inflation could be a mechanical accident rather than a deliberate exaggeration. Proposals along these lines have circulated for the better part of a century. None has achieved consensus, but the fact that serious people keep proposing them tells you something. The numbers bother the professionals too. They are not comfortable. They have never been comfortable. So that is the mainstream case. And it is coherent. And if you find it fully satisfying, you are in respectable company, and you should probably believe it. But hold the object in your mind for one more moment before you file it away, because there is a texture to it that the propaganda reading does not quite account for. The scribe who cut WB 444 was not a mystic. Everything else on that prism is the work of a technician, and a propagandist has an easier tool available than 250,000 years of imaginary kings. A propagandist can simply not give numbers. Vagueness is the propagandist's friend. Saying kingship descended from heaven in the beginning does all the political work you need. The moment you attach 28,800 to it, you have created a falsifiable claim in a culture that kept records, and you have created an arithmetic burden, and you have created the exact awkwardness that has embarrassed the document for 4,000 years. Why would you do that on purpose? The obvious answer is that he was copying, that he was working from something older, that the numbers were already in it, and that his job was fidelity rather than judgment. Scribal culture in Mesopotamia was ferociously conservative. The whole training system, the aduba, the tablet house, was built on copying, on reproducing exemplars exactly, on not improving your source. A scribe who found an absurd figure in his exemplar would very likely reproduce the absurd figure, because reproducing the exemplar was the job, and the exemplar was the authority. Which pushes the question backward rather than answering it. Fine, he copied. From what? And that source copied from what? The king list exists in multiple versions from multiple sites across several centuries, and they broadly agree, which means there was a stable tradition behind them, which means the numbers were old when the oldest copy we have was made. How old? Nobody can say, because we are already at the edge of writing itself. Behind the earliest tablet there is nothing but the possibility of speech, and speech leaves no residue. And then there is Berossus. Berossus was a Babylonian priest of Bel Marduk who lived around 300 years before the Common Era, roughly a millennium and a half after WB 444 was inscribed. In a world that had been conquered by Alexander and was being run by Greeks, he wrote a history of Babylonia in Greek, called the Babyloniaca, for a Greek-speaking audience, drawing on the temple archives to which he had access as a priest. The book itself is lost. What survives are quotations, preserved by later Greek and Roman and Christian writers who quoted him for their own purposes, and then quotations of those quotations. So the transmission is a chain of hands, and every hand is a place where something can change. With all those caveats standing, here is what comes down. Berossus gives a list of 10 kings before the flood. 10, not 8, though variant king list copies also run to 9 or 10 depending on the version. And Berossus gives their total reign as 120 sar. 120 times 3600 is 432,000. 432,000 years before the flood, from a Babylonian priest reading Babylonian archives 15 centuries after the Oxford Prism was made, in a completely different language, for a completely different audience, using the same base unit. And 432,000 is a number that has a strange career. Divide the Hindu Kali Yuga, and you get 432,000 years exactly. The full cycle of the 4 yugas is 4,320,000. The number turns up in the Rigveda's verse, counts by some reckonings. It turns up in the standard figure of 10,800 bricks, attributed to certain Vedic fire altars, which is 432,000 divided by 40. The Norse Grimnismal says that from Valhalla's 540 doors, 800 warriors will come at Ragnarok, and 540 times 800 is 432,000. Now, be careful here, because this is precisely the point at which a great many people stop being careful, and the whole edifice they build afterward is worthless because of it. Numerical coincidence is cheap. It is spectacularly cheap. Give a motivated person any target number and a free hand with multiplication, division, and selective reporting, and that person will find the target number in almost any dataset within an hour. This is not a hypothesis. It is a demonstrated fact, and the classic demonstration is the Great Pyramid, in which enthusiasts have located the speed of light, the polar radius of the Earth, the mean distance to the Sun, and the value of pi, all from the same handful of measurements, by varying which units they use and which stones they measure from. The technique is called numerology, and it has a perfect track record of finding whatever it is looking for. So the 432,000 cluster proves nothing on its own. Some of those instances are almost certainly cherry-picked. Some are almost certainly artifacts of the base 60 system itself, since 432,000 is 120 Shar, and any culture counting in Shar will produce Shar multiples constantly, and the Norse example in particular smells strongly of somebody working backward from the answer. The honest residue, after that acid bath, is smaller, but it is not zero. Berossus and the King List agree on the unit. They agree on the practice of measuring the antediluvian world in Shar. They agree that the deep past is enormous, and the near past is ordinary, and that something separates them. And the Indian material, whatever one makes of the coincidence, independently uses a cyclical cosmology with vast ages that shorten in sequence, which is the actual structural idea, and the structural idea is more interesting than the digits. Because here is what the Yuga system claims, stripped of arithmetic. It claims that history runs in cycles. It claims that each cycle has 4 ages, and it claims that the ages get shorter. The Satya Yuga is the longest, the Treta shorter, the Dvapara shorter still, and the Kali Yuga, the age we are told we are currently in, is the shortest of all, 1/4 the length of the first. The ages get shorter. Sit with that sentence, because it is the first time in this account that an ancient tradition has said something directly relevant to the thing you actually came here about. Not that time is long, not that the gods are old, that the periods are contracting, that the fundamental unit of an age is not constant across the sequence, and that the direction of change is toward the brief. The Mesopotamian material says something structurally similar without the explicit 4-stage architecture. Look at what the king list actually does as a shape rather than as a set of claims. The pre-flood kings hold power for tens of thousands of years each. After the flood, the first dynasty at Kish gives reigns in the hundreds, 1,200 years, 960. Then the numbers descend. They fall into the hundreds, and then into the double digits, and finally into the ordinary lifespans of ordinary men, at which point the document quietly becomes reliable history and stops being a scandal. The king list is not a flat inventory of implausible numbers. It is a decay curve. That is a description of the document, not an interpretation of it. Plot the reign lengths against position in the list, and you get a curve that falls off a cliff at the flood and then continues to erode, asymptotically, toward the human. Whatever the scribe thought he was recording, the shape he recorded is a shape of contraction. Something was long. Something happened. Now it is short. And it kept getting shorter for a while afterward before settling into what we would recognize as normal. The standard explanation for the shape is that it is an artifact of the transition from myth to memory. Of course, the numbers shrink as you approach the writer's own era. The near past is constrained by evidence, and the deep past is not. So the deep past inflates, and the near past cannot. The curve is a curve of information, not a curve of duration. It measures how much the scribe knew, not how long anything lasted. That is a very good explanation. It might be the whole explanation. But notice what it requires you to assume. It requires you to assume that the scribes understood themselves to be inventing, and that they simply had no material for the deep past and filled the gap with impressive figures. And the awkward thing is that we have no evidence for that assumption, and the scribes themselves say the opposite. They present the whole document as one document. They apply no discontinuity. The line about the flood sweeping over is delivered in the same voice as the line about Alulim, which is delivered in the same voice as the line about a king we can independently confirm from other inscriptions. To the scribe, apparently, 28,828 were the same kind of thing. That is either a failure of critical reasoning so complete that it undermines everything else the culture produced, in a civilization that was simultaneously doing quadratic equations and predicting eclipses, or it is telling us that the scribe believed the pre-flood years and the post-flood years were both real years, and were both being measured accurately, and that the difference between them was in the world, not in the record, which would mean that a year in the deep past was something other than what a year is now. That is a thought worth holding carefully, because it is about to be tested against a document that says it out loud. The document that says it out loud is called the Atrahasis Epic, and unlike a great deal of what gets waved around in discussions of this kind, it is not obscure, not disputed as to its existence, and not the property of any fringe. It is a standard text. It is taught in universities. The principal manuscript is a Babylonian copy from roughly 1700 years before the Common Era, written by a scribe who names himself at the end, a man called Ku-aya, which is one of those small details that punches through 4,000 years and lands somewhere in your chest. A junior scribe signed his homework, and the homework is now one of the oldest surviving long narratives on Earth. The story it tells begins before human beings exist, and it begins with a labor dispute. In the beginning, according to the text, there were the gods, and the gods worked. This is already unusual and worth stopping on. In most theologies, the gods do not work. Work is the mark of the creature. But the Mesopotamian gods dug. Specifically, the lower order of gods, called the Igigi, were assigned to excavate the river channels and maintain the irrigation, which in southern Iraq is not a metaphor for anything, it is the literal condition of survival. The Tigris and the Euphrates flood and silt and wander, and every canal must be dredged constantly, or the fields die and the cities die with them. The most fundamental fact of Mesopotamian life is that somebody has to dig forever, or everyone starves. And so their creation story says that in the beginning, the gods dug. The senior gods, the Anunnaki, supervised. Anu in the sky. Enlil holding the earth and the executive authority. Enki over the waters and the deep cunning. The Igigi carried the baskets. And the text says that they carried them for a long time. And the length of that time is exactly where the trouble starts. The line in question has been translated several different ways by several different scholars working from damaged clay, and honesty requires laying that out rather than picking the version that helps. Some renderings give the duration as 3,600 years. Others give figures in the low thousands with a question mark attached, because the sign is broken or ambiguous. A number of translators hedge entirely. What is not in dispute is that the text gives a number, that the number is large, and that the number is expressed in the shar system, which is to say in units of 3,600. Whether the Igigi dug for one shar or several is a question about a chipped corner of a tablet that they dug for shar is not a question at all. And then they stopped. What happens next in Atrahasis is one of the strangest scenes in ancient literature, and it is strange because of how modern it is. The Igigi do not rebel in the way gods rebel in later mythologies, with war in heaven and thrown thunderbolts. They organize, a meeting is held at night, grievances are discussed, and a course of action is agreed upon. Then they burn their tools, which is a specific and deliberate gesture, because burning your tools means you are not going back. And then they surround the house of Enlil, and they refuse to move. It is a strike. The oldest surviving account of a strike in the human record is in a creation myth, and the strikers are gods, and their complaint is that the work is too hard and has gone on too long. Enlil's response is to panic. He wants to know who started it. The gods hold an assembly, and in that assembly, Enki proposes the solution that gives the epic its entire meaning. He says, in effect, let us make a replacement. Let a new creature be brought into being to carry the basket, to bear the yoke that the Igigi bore, and to dig the canals so that the gods may be free. That creature is us. The manufacture is described with unsettling specificity. A mother goddess, called Nintu, or Mami, or Beletili, depending on the passage, mixes clay with the flesh and blood of a god who is slaughtered for the purpose. A god named Wi-ila, or A-ilu, and from that mixture humanity is formed. The text says that the god's ghost, or spirit, the Atemu, remains in the flesh, and that this is why human beings have a ghost, and why a drumbeat, the sound of the god's heart, persists in us. 14 pieces of clay, 7 male, 7 female. The birth goddesses squat and count the months, and the 10th month arrives, and mankind is born into the world already holding a shovel. Whatever you think this text is, notice what it is not. It is not flattering. There is no dignity in it. We were not made in love, we were not made in an image, and we were not made for our own sake. We were made because a workforce quit and management needed replacements, and the specification was durability and obedience, and that is the whole of it. Every other origin story in the world tells the human being that they matter. This one tells the human being that they are a solution to somebody else's problem. And then the story does something even more uncomfortable. It tells you what went wrong with the product. The humans multiply. That is the entire fault. Not sin, not disobedience, not eating anything. The text says that 1,200 years passed and the land was bellowing like a bull, and Enlil could not sleep because of the noise, the rigmu, the din of humanity. So he sends a plague. The humans, advised by Enki through the man Atrahasis, work around it. 1,200 more years pass, and the noise returns, and Enlil sends drought, then famine. Each time the population is culled, and each time it recovers and returns to full volume, and each cycle is 1,200 years. And finally, Enlil loses patience entirely and calls for the flood, and Enki, through a wall, tells Atrahasis to build a boat, and the flood comes, and one man and his household survive on a vessel. And afterward the gods, who have not eaten in 7 days because there is nobody left to feed them, descend on the survivors' sacrifice like flies. That is the Mesopotamian flood story, and it is on tablets that predate the Hebrew Bible by a wide margin, and its relationship to the Noah account is one of the least controversial claims in the study of the ancient Near East. When George Smith of the British Museum first read the flood tablet from the Nineveh Library in 1872 and realized what he was holding, the story goes that he began removing his clothes in the excitement. That is probably an embellishment. The excitement was not, but the flood is not why we are here. 1,200 is why we are here. There are 1,200 years between plague and drought, another 1,200 between drought and famine, another 1,200 of population recovery, 3 times over, and 1,200 is 1/3 of 3,600. It is 1/3 of a shar. And what the text is describing, when you strip away the divine personalities, is a periodic cycle with a fixed interval, and the interval is a fraction of the shar, and the shar is the 3rd position of the sexagesimal system. And the sexagesimal system is how these people measured the sky. A cycle, with a period, expressed in the units of astronomy. Hold that. Do not conclude anything from it. Hold it. Now go to the other great text, because the other great text is where the argument actually detonates, and almost nobody who talks about Sumerian time has read the relevant part of it, because the relevant part is boring, and the exciting parts are elsewhere. The Enuma Elish is the Babylonian creation epic, named as ancient texts often are for its opening words, when on high. 7 tablets, recovered principally from the library of Ashurbanipal at Nineveh, the same excavation that gave us the flood tablet, and known from multiple copies at multiple sites. It is the text everyone knows for 2 reasons. The first is Tiamat, the primordial saltwater being chaos in the shape of something enormous, whom the young god Marduk kills in single combat after the older gods prove unable to face her. The second is what Marduk does with the corpse. He splits her, the text says, like a dried fish, into 2 halves, and from one half he makes the sky, and from the other the earth. Her eyes become the sources of the Tigris and the Euphrates. The ribs become the vault. Her tail is bent up to hold the heavens in place. That is the famous part. It is genuinely great writing, and it is not what matters here. What matters here is Tablet 5, because after Marduk has built the universe out of a body, he does not rest. He organizes. And the first thing he organizes, before anything else, before humanity, before Babylon, before the temples, is time. Read what Tablet 5 actually says. Marduk establishes the stations for the great gods, meaning the constellations, and he fixes them in the sky as astronomical markers. He sets up the year and divides it. 3 stars are assigned to each of the 12 months, and the boundaries are defined. Then he causes the moon to shine and entrusts the night to it, and then he issues the moon a set of instructions so precise that it reads less like poetry than like a manual. Appear on the 1st day, grow horns to mark 6 days. On the 7th day, half a crown. On the 15th, stand in opposition to the sun, then diminish, then return. He is programming it. That is the only honest description of the passage. The moon is being given an operating cycle, phase by phase, with dates, and the god is specifying tolerances. And in the same tablet, he fixes the zenith, and he establishes the celestial pole, and he sets the courses of the 2 great luminaries, and he defines the region of the sky that is Anu's, and the region that is Enlil's, and the region that is Ea's, which is a real division that survived for 2,000 years in Mesopotamian astronomy as the 3 paths, an actual functioning coordinate system used by working observers who wrote down where things rose. The creation epic of Babylon is, at its structural center, an account of the installation of a calendar. Think about what that means as a claim about the world. It means that in this cosmology, time is not the stage, nor is it the empty container that events happen inside. Time is furniture. It is something a god built, on a particular occasion, out of specific decisions, after the universe already existed. The sky came first, and then somebody came along and put a clock in it. And anything that was built can be adjusted. That is not a mystical reading, That is the plain sense of the text. The Enuma Elish does not describe time as eternal or given or prior. It describes the year as a thing that was set up, the same way a canal is set up, by an authority who could have set it up differently, and who retains the authority to intervene. In the Babylonian New Year festival, the Akitu, this epic was recited aloud, and the recitation was not entertainment. The recitation was maintenance. Babylonians believed, and acted on the belief, for well over 1,000 years, that the ordering of time required annual reaffirmation, and that if the words were not said and the rites were not performed, the ordering could fail. The king was humiliated by the priest in that ceremony. He was struck across the face. His tears were required, and if he did not weep, it was a bad omen for the year. They were terrified that time would come apart if they stopped holding it together. That is a strange thing for a civilization to be terrified of. Most cultures fear famine, war, disease, the wrath of the sky. Those fears are legible. The Babylonians feared those things too, and had extensive procedures for them. But underneath all of it, there is this other anxiety, this structural one. And it is not about anything happening in time. It is about time itself. Where does an anxiety like that come from? The comfortable answer is that it comes from agriculture. In a floodplain, the calendar is life and death. Plant too early and the seed rots. Plant too late and the heat kills the crop. And the Mesopotamian calendar was lunar. And a lunar year runs about 11 days short of a solar year, which means it drifts, which means that without correction, the months walk backward through the seasons, and in 16 years, your harvest month lands in spring. So they intercalated. They inserted extra months by royal decree when the drift got bad. And the decision to insert a month was made by observation and authority rather than by rule, at least early on. Which means that in Mesopotamia, for centuries, the length of the year was literally a decision. A man in a palace decided how long this year would be. It was not a fact. It was an administrative act. That is the mundane explanation for the anxiety, and it is a strong one, and it may be sufficient. When the length of the year is a policy, of course you are nervous about the policy, but it leaves a residue, and the residue is this. Every other culture with a lunar calendar faced the same drift and solved it the same way, and none of them built their central religious festival around the terror that time would stop working. The Babylonians took an administrative inconvenience and turned it into a cosmological emergency that required the annual humiliation of the king. That is a disproportionate response. Disproportionate responses usually have a history. And in the middle of Tablet 5, in the middle of the calendar installation, there is a word. The word is Nibiru. Nibiru is the most abused word in the history of ancient studies, and the reason it is worth rescuing rather than discarding is that the abuse is recent and the word is not. Start with what is actually written in the actual text, in the actual passage, because almost nobody does this. Toward the end of Tablet 5 of the Enuma Elish, in the middle of Marduk's installation of the celestial order, the text names a station and says that it shall hold the crossing place of heaven and earth. The word for that station, in the Akkadian, is Neberu, which is also rendered Nibiru. And the word is not a proper name invented for the occasion. It is an ordinary Akkadian noun, built on an ordinary root. The root is the verb eberu, which means to cross over, to ford, to traverse. A Neberu is a ferry, a crossing point, a place where you get from one side of a river to the other. In a civilization built between two large rivers, this is about as unmystical a word as exists. It is the word for the shallow spot where you can bring the cart across. So, the sky has a ford in it. There is a place where something crosses. Tablet 7 returns to this, and is more explicit. Nibiru is called the one who holds the crossings. And the text says that the stars of heaven should keep to their paths, that they should not wander or go astray, and that Nibiru is the fixed point against which their regularity is judged. It is a reference marker. It is the nail in the wall that everything else is measured from. And outside the epic, in the working astronomical literature, the word behaves exactly like a technical term, because it is one. It appears in Mull. Apin, which is a real compendium, a 2-tablet astronomical handbook attested from around 1,000 years before the Common Era, and probably compiling material considerably older, containing star lists, rising dates, intercalation rules, and shadow-length tables. Genuine, functional, working astronomy. In that literature, Nibiru is associated most often with Jupiter, and sometimes with Mercury, and sometimes it appears to describe a position rather than a body, a place in the sky where a crossing occurs, most plausibly the point where a planet crosses the celestial meridian or reaches a particular station relative to the ecliptic. That is what the tablets say. A crossing point, a marker. Probably Jupiter. Definitely not a wandering catastrophe. Now here is what happened to it. In 1976, a man named Zecharia Sitchin published a book called The 12th Planet, and it sold, and it kept selling, and it spawned a series, and the series has now shifted something in the range of millions of copies in dozens of languages, and it is very likely the reason you have ever heard the word Anunnaki at all. Sitchin's thesis, compressed, is this. Nibiru is a planet. He counts it as the 12th body in the solar system, a tally that includes the sun and the moon. It is on a long elliptical orbit that brings it back into the inner solar system periodically, and the period of that orbit is 3,600 years, which is one shar. The place is inhabited. The inhabitants are the Anunnaki, who came here from it, and who mined gold in southeastern Africa, and who genetically engineered humanity from an existing hominid to be their mining labor, and who are described doing all of this, plainly, in the Sumerian tablets. If only you would read them properly. He argued this at length and with an enormous apparatus of apparent scholarship. Citations, transliterations, cylinder seal illustrations. The books look like scholarship. They are shaped like scholarship, and for a very large number of readers, over 50 years, they have functioned as scholarship. They are not scholarship, and it is necessary to say why with precision. Because vague dismissal is worthless, and because the specific ways the argument fails are more interesting than the fact that it fails. Take the cylinder seal, because it is the single most reproduced image in this entire field. The object is real. It is catalogued VA243. It is in the Vorderasiatisches Museum in Berlin. And it is an Akkadian seal from roughly the middle of the 3rd millennium, before the Common Era. It shows figures seated and standing, and above them, in the upper field, a circle surrounded by a ring of smaller dots. Sitchin identified this as a depiction of the solar system, with the sun in the center and the planets around it, and counted the dots, and found more bodies than the classical count allows, and declared the extra one to be Nibiru, and further declared that the arrangement proves the Sumerians knew of Uranus and Neptune and Pluto millennia before telescopes. The problems with this are numerous, and none of them require you to trust anyone's authority, because you can check them. First, the central object is not drawn the way the Sumerians drew the sun. The sun sign in Mesopotamian iconography is well established and consistent. It has rays, typically 4, with wavy lines between them. The object on VA243 is a dotted rosette, which is a common decorative and symbolic motif with an entirely different range of meanings, often stellar or divine in a general sense. Second, the dots do not correspond in size or spacing to any planetary arrangement. The size ordering is wrong, the spacing is wrong. If you want the Sumerians to have known the relative sizes of the outer planets, this object does not deliver it, and the only way to make it deliver is to assert the correspondence and then not check it. Third, and this is the one that should end the discussion, the seal has an inscription on it. Cylinder seals are personal property. They are signature devices. They usually say who owns them. This one does, and the inscription has been read, and it names an individual, a scribe. And it is a perfectly ordinary ownership inscription of exactly the type you find on thousands of other seals. Nothing in it describes a solar system. Nibiru is not mentioned anywhere on the object. The text says whose seal it is. The image is a man's business card, and it has been circulating for 50 years as a star map. Deeper failures are linguistic, and they are harder to see from outside the field, which is precisely why they have been so durable. Sitchin's translations do not match the standard lexica. When he renders a Sumerian or Akkadian term, he frequently assigns it a meaning that no dictionary of the language supports, and the meaning he assigns is always the one that advances the thesis. The word Anunnaki is the clearest case. It is a real term. It appears constantly, and its plain reading is well established. Anuna is a collective name for a class of gods, and the key element is the ordinary Sumerian word for earth or ground. The standard understanding across the field is something along the lines of the princely offspring, or those of royal seed, or, with the key, the Anuna of the earth, which in the Mesopotamian religious system means the chthonic gods, to ones associated with the underworld and the earth as opposed to the Igigi who are associated with the heavens. Sitchin renders it as those who from heaven to earth came. That is not a translation. It is a sentence, imported. The rendering requires elements that are not in the word. A verb of motion that is not present, a direction that is not present, and a subject that is not present. It is the thesis wearing the word as a costume. And once you have accepted that translation, the entire book follows, because the name of the beings now contains the claim about the beings, and every subsequent appearance of the word looks like corroboration, when it is nothing but the same assertion repeated. The orbital claim collapses just as completely, and it collapses on physics rather than philology. An object on a 3,600-year orbit around our sun would have an aphelion somewhere in the region of hundreds of astronomical units. It would spend the overwhelming majority of that period in the deep outer dark, and its perihelion passage, on Sitchin's account, brings it through the inner solar system, between Mars and Jupiter, repeatedly, every 3,600 years, which is to say roughly 1,300 times over the age of the solar system. Run that. A massive body cutting through the asteroid belt and the inner planets 1,300 times does not leave the inner solar system looking like this. It leaves it looking like wreckage. The orbits of the terrestrial planets are stable and nearly circular and coplanar to a striking degree, and that configuration is not compatible with a large intruder plowing through it on a regular schedule since the beginning. We would see the damage. The damage is the easiest thing in the world to look for, and it is not there. And there is the additional and rather awkward point that we have looked for the object directly. The infrared surveys of the 1980s and the wide-field surveys since have covered the sky repeatedly at wavelengths where a large cold body radiates, and the search has been thorough enough to place hard limits on what can be out there undetected. A Saturn mass object within 10,000 astronomical units is excluded. A Jupiter mass object within roughly 26,000 is excluded. Nibiru, as described, would be trivially detectable, and it is not detected. And the reason it is not detected is not a conspiracy, because the surveys that would have found it were conducted by hundreds of independent teams across many countries with no common interest and a powerful incentive to be the ones who found a planet. So that is the demolition, and it is total, and anyone who tells you otherwise is either uninformed or selling something. Now the harder part. Because the collapse of Sitchin's answer does not vaporize the questions that made his book sell 4 million copies, and a great many people who correctly reject his conclusions have never actually engaged with the observations underneath them. Two things can be true at once. A man can be wrong about everything he claims, and still have been pointing at something that is genuinely odd. The pointing is not validated by the claims, and it is not invalidated by them either. What was he pointing at? He was pointing, first, at the Shar. At the fact that a real, attested, working unit of 3,600 sits in the middle of the Mesopotamian material and gets attached to durations of history as no other ancient culture quite reproduces. He then did something stupid with it, namely declaring it an orbital period on no evidence whatsoever. But the Shar was there before he arrived, and it is still there now that he is gone. He was pointing, second, at the King List's decay curve. At the shape, he explained the shape badly, with a planet, but the shape is in the document, and the document is in Oxford. He was pointing, third, at the sheer strangeness of Mesopotamian astronomical attention. And this is the one that survives him most intact, because it is not an interpretation of a text. It is a fact about a civilization. These people watch the sky with an intensity that has no obvious payoff. Understand the scale of it. The Babylonian astronomical diaries are a continuous observational record. Night after night, for centuries, scribes wrote down the positions of the moon and the planets, the weather, the level of the river, the price of barley and wool and dates and sesame, and any unusual event. The surviving run of these diaries covers, with gaps, something on the order of 7 centuries. 7 centuries of nightly observation, maintained across the fall of the Assyrian Empire, across the Persian conquest, across Alexander, across the Seleucids, by an institution that simply did not stop. It is the longest continuous scientific project in the history of the human species, and nothing else is close. Modern science, as an institution, is roughly 400 years old. The Babylonians ran their program for longer than that and then kept going. And what did they get for it? They got eclipse prediction, which is genuinely useful for omens and is a real intellectual achievement. Out of the raw logs, they pulled the Saros cycle, the 18-year period after which the sun and moon and nodes returned to nearly the same relative configuration, which is a subtle thing to extract, and which they extracted. Planetary period relations of high accuracy came out of the same data. Then came the mathematical astronomy of the late period, the System A and System B lunar theories, which are computational schemes that predict lunar phenomena using arithmetic progressions, and which work, and which are, by any reasonable definition, the first mathematical physics. But the payoff, in agricultural terms, in practical terms, is wildly out of proportion to the effort. You do not need 7 centuries of nightly logs to know when to plant. You do not need System B lunar theory to run a canal. The Babylonians were doing something that cost enormous resources over enormous time for reasons that the practical explanation does not cover. The standard account says the reason was omens, that all of this was in service of divination, that they watched the sky because the sky was the message board of the gods and the king needed to know what was coming. And that is well documented and certainly true as far as it goes. The Enuma Anu Enlil is a real series, roughly 70 tablets of celestial omens, and the correspondence between court astronomers and Assyrian kings survives and is full of exactly this. When Jupiter does this, the king should do that. But notice that the omen explanation explains the interpretation and not the recording. You do not need to write down the price of barley alongside the position of Mars for 700 years to run a divination practice. That is not divination. That is data collection with a hypothesis attached. And the hypothesis appears to be that celestial events and terrestrial events are correlated, and the method is to log both and look for the pattern. They were correlating the sky against the world, systematically, for 7 centuries, and writing down both columns. That is not superstition. That is, procedurally, the thing we now call science, run on a wrong hypothesis for longer than the correct hypothesis has been running. And the question that nobody has a good answer to is why they thought it was worth doing. What made a civilization commit that level of resource, across that many political collapses, to the proposition that the sky and the ground are connected and that the connection can be found by watching long enough? The answer they give, when asked, is in the texts. They believe the sky had been set up deliberately, by someone, on a schedule, with a marker at the crossing point, and they believed that a thing which had been set up once could be set up differently. There is one more piece of Mesopotamian skywork that has to be laid on the table before any of this can be assembled, and it is the piece that connects a Bronze Age clay tablet to the physical rotation of the Earth, which is where this account is eventually going. The Babylonians invented the zodiac, not a version of it, not a precursor. The 12-sign zodiac, the one in the newspaper, the one on the wall of every waiting room, the division of the ecliptic into 12 equal segments of 30 degrees each named for constellations, is a Babylonian invention, and it can be dated with reasonable confidence to somewhere around the 5th century before the Common Era, and it comes out of the same scribal tradition that produced the diaries. Before that, they had a longer and messier list of constellations along the moon's path, sometimes 17 or 18 of them, of unequal size, which is what you actually see when you look at the sky, because the real constellations are not equal and the sun does not spend equal time in them. The 12-sign zodiac is a normalization. It is the imposition of a clean mathematical grid onto a messy observational reality, so that positions can be computed rather than merely noted. 12 segments, 30 degrees each, 360 total. The same numbers as the day, the same numbers of creators. The circle, the same system running everywhere. And that grid, once you have it, makes something visible that is otherwise almost impossible to see. It makes drift visible. Here is the phenomenon. The Earth spins on an axis, and that axis is tilted relative to the plane of its orbit, and the axis is not fixed. It wobbles. Slowly. Think of a spinning top losing energy, tracing a cone with its upper point. Our axis traces a cone in exactly that way, and the period of the wobble is roughly 25,772 years. The cause is well understood and is not controversial. The Earth is not a sphere. It bulges at the equator because it is spinning. The sun and the moon pull on that bulge, and because the bulge is tilted relative to their pull, the pull produces a torque, and a torque applied to a spinning body does not tip it over, it makes it precess. Same physics as the top. Our moon does most of the work because it is close. The sun helps. What results is a slow conical sweep of the north celestial pole through the northern sky, taking roughly 26,000 years to come back around. The consequences are entirely practical, and they are the reason this matters to anyone with a calendar. First, the pole star changes. Polaris is not permanently the pole star, and has not always been. Around 3,000 years before the Common Era, the pole was near a star called Thuban in Draco, and Thuban was the pole star of the Egyptians and, in the same era, of the Sumerians. In roughly 12,000 years, the pole will be near Vega. This is not speculation, it is geometry, and you can compute it to arbitrary precision, forward and backward. Second, and far more importantly, the equinox moves. The vernal equinox is the point on the ecliptic where the sun crosses the celestial equator going north, and it defines the beginning of the solar year. And because the axis precesses, that point slides backward along the ecliptic against the background stars at a rate of roughly 1 degree every 72 years, which means it moves through an entire 30-degree zodiac sign in roughly 2,160 years. which means it moves through all 12, all 360 degrees, in roughly 25,920 years. 25,920. That is the number you get if you take the modern zodiac grid and the classical precession rate of 1 degree in 72 years and multiply it out. The actual physical figure is closer to 25,772 because the rate is not perfectly constant. But the classical value, the one the ancients used and the one that appears throughout the tradition, is 25,920. Look at that number in sexagesimal terms. 25,920 is 72 times 360. It is also 432 times 60. It is also 12 times 2,160. The Great Year, as the classical world called it, sits inside the Sumerian number system like a key in a lock, and 432 is the same 432 that runs through Berossus and the Kali Yuga and everything else in this account. That may be meaningful. It may also be exactly what you would expect from a system built on 60, because a system built on 60 produces multiples of 60 everywhere, and finding 60 in the output of a base 60 machine is not a discovery, it is a tautology. Both of those statements are true at once, and neither cancels the other. Keep both. The historical question, the one that actually has stakes, is who knew about precession and when? The textbook answer is Hipparchus of Nicaea, around 130 years before the Common Era. Hipparchus compared his own careful measurements of certain star positions against records from roughly a century and a half earlier, made by Timocharis and Aristillus in Alexandria, and noticed that the stars had shifted relative to the equinox by an amount too large to be observational error, and concluded that the equinoxes were moving. He estimated the rate at not less than 1 degree per century, which is in the right neighborhood, and slightly slow. That is the standard account of the discovery of precession, and Hipparchus deserves the credit, and the credit is not in serious dispute among historians of astronomy. But there is a wrinkle, and the wrinkle is that Hipparchus was working from Babylonian data. This is not a fringe claim. It is a mainstream position, developed principally by Otto Neugebauer, who was the 20th century's most formidable historian of ancient mathematical astronomy, and who was, if anything, aggressively hostile to romantic readings of ancient science. Neugebauer demonstrated that Hipparchus used Babylonian period relations, Babylonian eclipse records, and Babylonian arithmetic methods, and that the transmission from Mesopotamia to Greek astronomy was direct and substantial. Greek astronomy did not spring from nothing. It was built on a Babylonian foundation that had been accumulating for centuries, and the Greeks knew it and said so. So the question sharpens. Hipparchus discovered precession using Babylonian data. Did the Babylonians, who generated the data, and who kept it for 700 years, and who had the mathematics, and who were obsessive about exactly this kind of pattern, never notice? The honest answer is that we do not have a Babylonian text that states the precession of the equinoxes as a general phenomenon. If such a tablet exists, it has not been found, or it has not been read, and given how much material sits untranslated, the second possibility is not rhetorical. There are hints. There are scholars who have argued that certain Babylonian systems appear to incorporate a slow shift. Some have pointed to the fact that late Babylonian sidereal and tropical schemes coexist, which would require somebody to have noticed they were diverging. None of it is conclusive. The mainstream position is that they did not have it as a concept, and the mainstream position is probably correct. But here is what is not in dispute, and what does not require the Babylonians to have understood precession at all. The zodiac drifted, and everyone noticed the drift, and the noticing is recorded. By the classical period, the constellation names and the zodiac signs had come apart. The sign called Aries, the first 30 degrees of the ecliptic measured from the vernal equinox, no longer contains the stars of the constellation Aries. It has not for a very long time. Somewhere around the beginning of the Common Era, the vernal equinox left the constellation Aries and moved into Pisces, and it now sits on the border of Pisces and Aquarius, which is where the entire notion of an age of Aquarius comes from. And that notion, whatever you think of what got built on top of it, is founded on a real astronomical fact that anyone with a telescope can confirm tonight. The sky is sliding. The grid the Babylonians laid down is no longer where they laid it. And the reason it slides is that the Earth's spin axis is not stable, which is a way of saying that the Earth's rotation, the thing that defines the day, the thing that is the physical basis of every clock ever built until the middle of the 20th century, is not a fixed and reliable thing. It moves. It has always moved. And the ancients built their entire timekeeping apparatus on top of it and then spent 1,000 years being nervous. Now push on that, because this is the hinge. What is a day? The obvious answer is one rotation of the Earth. And the obvious answer is wrong twice over. First, one rotation of the Earth relative to the distant stars, the sidereal day, is about 23 hours and 56 minutes, roughly 4 minutes short of what your clock calls a day. The reason is that the Earth is also moving around the Sun, so after one full spin, it has to turn a little further to bring the Sun back to the same place in the sky. The day you actually live in, the solar day, is a compound of two motions, not one. Second, and worse, the solar day is not a constant length. It varies through the year, because the Earth's orbit is elliptical, and its speed changes, and because the axis is tilted. The difference between apparent solar time, which is what a sundial reads, and mean solar time, which is what a clock reads, runs to something like 16 minutes at the extremes. There is a chart of this discrepancy that has been known for centuries. It is called the equation of time, and the figure 8 shape you sometimes see printed on old globes, the analemma, is a picture of it. So the sundial and the clock disagree, all year, every year, by up to a quarter of an hour. And this has been known since antiquity, and the solution was to define the day as an average, rather than as a measurement. The mean solar day, a fiction, a useful one, but a fiction, arrived at by taking real days, which are all different lengths, and averaging them into a day that no actual day ever is. Every clock you have ever looked at is displaying an average of something that does not have a stable value. That is worth stopping on for a second, because it is not a philosophical point. It is engineering. The second, the base unit of time, was for most of its history defined as 1/86,400th of a mean solar day. Take the day, divide by 24, then by 60, then by 60 again. Sumerian arithmetic all the way down, applied to a rotation that is not constant, averaged into a number that is stable only because we declared it to be. And in the middle of the 20th century, that stopped being good enough, because the instruments got better than the planet. By the 1930s, quartz oscillators were accurate enough that astronomers using them to time stellar transits started noticing something inconvenient. The discrepancies were not in the clocks. When you have two quartz clocks and they agree with each other and they both disagree with the Earth is the thing that is wrong. Nicolas Stoico in Paris reported seasonal variation in the Earth's rotation rate in the 1930s. The planet was found to be speeding up and slowing down through the year by small amounts, on a schedule. The Earth is a bad clock. That was the finding. The oldest clock we have, the one every civilization built its calendar on, the one Marduk was supposed to have installed, turns out to wobble, so we replaced it. In 1967, the second was redefined. It is no longer a fraction of a day. It is defined as 9,192,631,770 periods of the radiation, corresponding to the transition between the two hyperfine levels of the ground state of the cesium-133 atom. That is the definition. It has nothing to do with the Earth. Nothing about the sun or the sky or the year enters into it. And no Sumerian would recognize any part of it. It is a property of an atom, and it is the same in a basement in Colorado as it is on the far side of the galaxy. We cut the second loose from the planet, and the moment we did that, we created a problem that nobody had ever had before, and that problem is the subject of the rest of this account. And it is, right now, in this decade, doing something that was not predicted. Because if the second is defined by an atom, and the day is defined by the Earth, then the day is no longer an exact number of seconds, and the two will drift apart. And somebody has to decide what to do about it. The system we built to handle it is more improvised than you would expect from something the entire technological world depends on, and understanding the improvisation is the only way to understand what has gone wrong with it. There are, functionally, two kinds of time running on this planet right now, and they do not agree. The first is atomic time, called TAI, from the French. It is produced by a network of several hundred atomic clocks in dozens of laboratories across many countries, whose readings are collected and weighted and averaged into a single scale by the International Bureau of Weights and Measures outside Paris. TAI is a count. It counts cesium transitions and it does nothing else. Neither the sun nor the sky enters into it at any point. TAI has been counting since 1958, and it has never skipped, and it never will, and it is, for all practical purposes, perfect. The best clocks feeding into it now would not gain or lose a second over a span longer than the age of the universe. The second is universal time, called UT1. It is the rotation of the Earth. It is measured by actually looking. The technique is called very long baseline interferometry, and what it does is point radio telescopes on different continents at quasars, which are so absurdly distant that they function as fixed points, and then compare the arrival times of the signal at each dish. From that you can compute, with extraordinary precision, exactly how the Earth is oriented in space at that moment, and therefore exactly how far through its rotation it has gotten. UT1 is the modern, high-technology, laser-precise version of exactly what the Babylonians were doing when they watched a star cross the meridian and wrote it down. Same measurement, same principle. Better dish, TAI is the atom. UT1 is the planet. And the planet loses? The Earth's rotation has been slowing down for as long as there has been an Earth. And the mechanism is the moon. Tides. The moon raises a bulge of water on the Earth, and the Earth's rotation drags that bulge slightly ahead of the moon, and the bulge then pulls the moon forward gravitationally, which boosts the moon into a higher orbit, and the reaction to that boost is a drag on the Earth's spin. Angular momentum is conserved. The Earth loses spin. The moon gains orbit. The moon is receding from us at about 3.8 centimeters a year. And that number is not inferred. It is measured directly by bouncing lasers off the retroreflector arrays that the Apollo missions left on the lunar surface. You can rent time on the equipment. The measurement is that solid. And the corresponding effect on us is that the day is getting longer, at a rate on the order of 1.7 to 2.3 milliseconds per century. Run that backward and it gets vivid. In the late Cretaceous, when the large dinosaurs were still walking around, the day was roughly half an hour shorter than it is now, and there were something like 372 days in a year. That is not a guess. It comes from rudous bivalve shells, which laid down daily growth bands and annual patterns. And you can literally count the days in a year off a fossil shell from 70 million years ago. It has been done. The count comes out to 372. Go back further, to the Devonian, and it is around 400. Go back to the early Earth, shortly after the moon formed, and the day may have been 6 hours long, and the moon filled a large part of the sky. The day has been getting longer for 4.5 billion years. That is the trend, and that is the physics, and none of it is in question. So when the second was cut loose from the Earth in 1967 and pinned to the cesium atom, the expectation was straightforward. The atomic day, 86,400 atomic seconds, would be slightly shorter than the real day, because the real day was slowly growing. Atomic time would run ahead. The planet would fall behind, and the gap would need to be closed periodically. The solution, adopted in 1972, was the leap second. The rule is that UT1 and the broadcast civil scale, UTC, must never differ by more than 9/10 of a second. When the gap approaches that limit, a body called the International Earth Rotation and Reference Systems Service issues a bulletin, and on the appointed date, at the end of the appointed day, an extra second is inserted. The clock reads 58, 59, 60, and then 0. There is a minute in the record with 61 seconds in it. This has happened 27 times. Every single one of them has been an insertion. Every single one has been a case of the atom waiting for the planet to catch up. That is the system. It is, when you look at it directly, an astonishing thing. The most precise measurement humanity has ever achieved, the cesium standard, is periodically stopped and made to hold still by committee, so that it does not get too far ahead of the rock we are standing on. We built a clock better than the Earth and then chained it to the Earth anyway, because we could not bear for noon to drift. The Babylonian king inserted a month when the calendar drifted. A commission in Paris inserts a second when the calendar drifts. 4,000 years, and the procedure is identical, and the anxiety underneath it is identical, and the only thing that has changed is the size of the correction. Leap seconds are also, in engineering terms, a catastrophe. They break things. Because a leap second means that a minute can have 61 seconds in it, and essentially no software in the world was written with that possibility in mind, and the assumption that a day has 86,400 seconds in it is baked into an incalculable number of systems at a level far too deep to audit. The leap second of June 30th, 2012, took down Reddit. It took down Mozilla's systems. It took down LinkedIn, Yelp, Foursquare, and a number of airline reservation systems, most visibly Qantas, which had to check passengers in by hand. The cause was traced to a race condition in the Linux kernel involving how the operating system handled the inserted second, and the failure mode was that the processors pegged at full utilization and stayed there. A 1-second insertion, announced 6 months in advance, publicly, with full documentation, broke large parts of the internet because the number 86,400 was welded into too many places for anyone to find them all. Google's response to this is worth knowing, because it is the most elegant admission of defeat in modern engineering. Google does not do leap seconds. Instead, Google smears them. When a leap second is coming, Google's internal clocks are slowed down very slightly across a window of many hours, so that the extra second is absorbed gradually, and no clock ever displays a 61st second. For that window, a Google second is not a second. It is slightly longer than a second, deliberately, so that the systems never have to confront the discontinuity. Read that again. In order to keep the software from breaking, one of the largest computing operations on Earth deliberately runs time slow for a day. And the world does not notice, and nothing depending on it notices, because the alteration is small and smooth, and everything inside the system is altered together. The implications of that are worth carrying forward, and we will come back to them, because they bear on the entire question. Time was changed. Nobody inside noticed. The change was undetectable from inside precisely because it was applied to everything at once, including the instruments. Now, 2020. Everything above describes a planet that is slowly slowing down, requiring periodic insertions, on a trend that is held for 4.5 billion years and that was expected to continue and in fact to accelerate slightly, requiring more frequent leap seconds as the centuries passed. That is not what happened. Starting around 2016 and becoming unmistakable in 2020, the Earth began spinning faster. Not slower, faster. The days began coming in short. On July 19th, 2020, the day was about 1.47 milliseconds shorter than 86,400 seconds. That was, at the time, the shortest day ever recorded since precise measurement began. And it did not stand for long, because 2020 produced 28 of the shortest days in the entire record. And then 2021 was fast, and 2022 was faster, and on June 29th, 2022, the day came in about 1.59 milliseconds short, breaking the record again. Then July 5th, 2024, went shorter still, at roughly 1.66 milliseconds. And 2025 continued the pattern, with a cluster of short days in July and August, and the July 9th measurement coming in around 1.3 to 1.5 milliseconds under. There is a further detail that makes the pattern harder to wave away. The speedup is not a smooth ramp. It arrives in clusters, concentrated in particular months, most often in July and August, superimposed on the ordinary seasonal breathing of the atmosphere that has been known since the 1930s. So the signal is not one thing. It is a short-term seasonal oscillation, riding on a multi-year trend, riding on a 4.5 billion year deceleration, and the three are running in different directions at different magnitudes at the same time, and separating them is genuinely difficult work that a small number of people do for a living and argue about. Every one of those numbers is published. They come from the International Earth Rotation and Reference System Service. They are updated continuously, and anyone can pull the data. There is no secrecy, there is no controversy about the measurement. The Earth is, at this moment, rotating faster than it has at any point since we have been able to check. The magnitudes sound trivial, a millisecond and a half, but hold the trend against the baseline. Tidal breaking has governed the length of the day since the moon formed, and it produces a change of about 2 milliseconds per century. The recent speedup has produced changes of comparable size across a handful of years. Short-term variation is running roughly 2 orders of magnitude faster than the long-term trend, and it is running in the opposite direction. The consequence is the thing that has never happened before. Because the Earth is running fast, atomic time is falling behind the planet rather than getting ahead of it, and the gap that leap seconds exist to close is closing on its own, and then continuing past zero in the other direction, which would require, for the first time in the history of the system, a negative leap second, a second deleted, a minute in which the clock reads 57, 58, and then 0, with 59 simply not occurring. This is not a thought experiment. It is an active operational concern among the people whose job is timekeeping, and it has been discussed in the technical literature and in the general press, with estimates that the first negative leap second might be required somewhere around the end of this decade, though the estimates keep moving because the underlying rotation keeps changing. The leading work on this, published in Nature in 2024 by Duncan Agnew at Scripps, made the additional and rather grim point that the melting of the polar ice is itself slowing the rotation slightly by moving mass from the poles toward the equator, and that this melting is partially masking the speedup and delaying the negative leap second by a few years. Which means the two most consequential things happening to the planet right now, the ice and the spin, are entangled in the definition of the second. And if a positive leap second broke Reddit and Qantas and the Linux kernel, Nobody has any confidence whatsoever about what a negative one would do, because a positive leap second is at least a case of extra time, and software that mishandles extra time usually just stutters. A negative leap second means a moment that does not exist. It means a timestamp that is valid on Tuesday and invalid on Wednesday. It means that any system anywhere that assumes time is monotonic and complete has to be right about a case that has never occurred in the entire history of computing. So why is the Earth speeding up? The honest answer is that nobody fully knows, and the people who work on it say so plainly. And this is one of the rare cases where the scientific literature is comfortable using the word unexplained without embarrassment. There are candidates, and they are real. The core is one. The Earth has a solid inner core and a liquid outer core, and the inner core is not rigidly locked to the mantle. It can rotate at a slightly different rate, and the coupling between core and mantle exchanges angular momentum. Research published in 2023, principally out of Peking University, found evidence that the inner core's rotation relative to the surface had paused and possibly reversed around 2009, and that it appears to run on a multi-decadal oscillation, with a period of roughly 70 years. If the core slows, the mantle must speed up, because the total has to be conserved. That would show up exactly as this. A surface that starts spinning faster for reasons that are entirely internal and entirely invisible. Nobody has ever seen the core. Nobody ever will. Everything we know about it is inferred from seismic waves passing through it, and the inference is difficult and contested, and the 2023 result has been argued about ever since. But the mechanism is sound, and the timing is suggestive. The atmosphere is another. Wind carries angular momentum, and the jet streams are enormous. And when the atmosphere speeds up, the solid Earth must slow down, and vice versa. This produces the seasonal signal that Stoico found in the 1930s, and it is well modeled. But it is not big enough to account for the multi-year trend, and it is periodic rather than cumulative. The oceans, the glacial rebound of continents still rising after the ice sheets left them, the redistribution of water into reservoirs, the mass movement from great earthquakes. The 2004 Sumatra earthquake shortened the day by about 2.6 microseconds by moving mass toward the center of the Earth, which is a real measured effect and a genuinely eerie one, since it means a subduction event killed 250,000 people and also changed the length of every subsequent day forever, by a tiny amount, permanently. All of these are real, and all of them are being modeled, and none of them, together, cleanly accounts for the trend that began around 2020. The best current position is that it is probably the core, that the core operates on a cycle we have observed for less than one full period, and that we are inside a phase of that cycle that we have no historical record of, because precise measurement of the rotation is barely a century old and the cycle appears to be 70 years long. We have watched this system for less than 2 of its periods. We are, in the most literal sense, extrapolating a curve from 1.5 data points. And the thing that started around 2020 was not predicted by anyone. Before we move on to the 2 clocks, stop. What you just heard about the speed up only makes sense on the full timeline, next to the 6 resets before it. 6 resets, then us. The signs are here. It's all in the 7 resets, linked below. Grab it, come back. What's next builds on it. QR code is on your screen. Before going any further with the planet, there is something that has to be established about time itself, because the entire discussion so far has been carrying an assumption that is false, and its falsity has been experimentally confirmed thousands of times and is currently being relied upon by the device in your pocket. Time is not a constant. Not as a metaphor. Not as a figure of speech about how the summer felt long. As a matter of established physics, verified to absurd precision, and engineered around commercially. The rate at which time passes is a local variable. It depends on where you are and how fast you are moving, and 2 identical clocks in different places will genuinely, physically, permanently disagree, with neither of them broken. This is the part of the story where the ancient material and the modern material stop being 2 separate conversations, because the Babylonians believed the rate of time was something that could be set, and they were mocked for it for 2,000 years. And then, in 1915, a patent clerk in Bern published a set of field equations which say that the rate of time is set, locally, by mass. Take the simpler piece first. Special relativity, 1905. A clock in motion relative to you runs slow, not appears to, runs. The effect scales with velocity and only becomes noticeable near the speed of light, which is why nobody noticed it for the whole of human history. But it is not a fringe effect at high energies. It is the dominant fact. Muons are the standard demonstration. A muon is a particle produced when cosmic rays hit the upper atmosphere, roughly 15 kilometers up, and a muon at rest decays with a half-life of about 1.5 microseconds. Even traveling at essentially light speed, a muon should get about 450 meters before decaying. It should never reach the ground. There should be no muons at sea level at all. Detectors at sea level are full of muons. They arrive in enormous numbers. The arrival happens because from our frame, their internal clocks are running slow, so their half-life is stretched, and they survive the trip. From the muon's own frame, nothing unusual happens to its clock at all. But the 15 kilometers of atmosphere is contracted to a few hundred meters, and it crosses that easily. Both descriptions are correct. The disagreement is not an error. It is the structure of the thing. Now the harder piece, and the one that matters here. General relativity, 1915. Mass curves space-time, and one consequence is that a clock deeper in a gravitational field runs slower than a clock higher up. Time passes more slowly near mass. The bottom of a mountain is running behind the top permanently, and the gap is opening right now, and it will never close. The size of the effect is normally described as too small to matter, and for most of the 20th century that was true. It is not true anymore, and the reason it is not true is the single most beautiful experimental result of the last 20 years, and almost nobody outside physics has heard of it. In 2010, a team at the National Institute of Standards and Technology in Boulder, working with aluminum-ion optical clocks, raised one clock relative to the other by 33 centimeters. 33 centimeters, about a foot, the height of a stack of books. And they measured the difference in the rate of time between the two clocks. And it was there, and it matched the prediction of general relativity, and the higher clock ran faster. That is the experiment. A foot of altitude in a laboratory in Colorado is enough to measurably change the rate at which time passes, given a good enough clock. Which means that if you are standing up, your head is aging faster than your feet. Over a lifetime, the accumulated difference is on the order of tens of nanoseconds, so nobody is going to notice. But the point is not the magnitude. The point is that the effect exists at the scale of a human body in an ordinary room, and it is not a theoretical prediction anymore. It is a laboratory measurement that has since been repeated and refined until modern optical clocks can resolve height differences of a centimeter or less. The clocks have gotten so good that they are now being used as altimeters. There is a field called relativistic geodesy which proposes to survey the shape of the Earth's gravity field by putting clocks in places and seeing how fast they tick. The rate of time is a surveying instrument. That is a real thing that real people are really doing with real funding. And the practical consequence, the one that touches you personally every day, is the satellite navigation system. The satellites are roughly 20,000 kilometers up, which puts them in a weaker gravitational field, so their clocks run fast relative to the ground by about 45 microseconds a day. They are also moving at about 14,000 kilometers an hour, which by special relativity makes their clocks run slow by about 7 microseconds a day. The two effects do not cancel. The net is that the satellite clocks gain roughly 38 microseconds every day relative to the surface. 38 microseconds sounds like nothing, but the system works by timing radio signals traveling at the speed of light, and light covers about 30 centimeters in a nanosecond, so an error of 38 microseconds is an error of about 11 kilometers of position per day. Cumulative. If the engineers had not built the relativistic correction into the system, satellite navigation would have degraded to uselessness within about 2 minutes of being switched on, and would have been off by 10 kilometers by the end of the first day, and would have kept getting worse forever. The correction is not an afterthought. The oscillators are deliberately tuned to the wrong frequency before launch, so that once they are in orbit and time is running at a different rate for them, they will tick at the right rate as seen from the ground. We manufacture clocks that are wrong on purpose, so that they will be right after we change the rate of their time by moving them. This is the situation. Every phone, every ship, every aircraft, every ambulance, every agricultural combine steering itself down a row, every trade time-stamped on an exchange, is depending on an engineering correction for the fact that time does not run at a fixed rate. It is not an exotic claim. It is infrastructure, as settled and as mundane as the fact that metal expands when you heat it. So when a Babylonian priest says that the rate of time was established by a decision and can be altered, the modern response cannot be that this is absurd on its face. The rate of time is a local variable. It is set by conditions. Change the conditions and you change the rate. And the change is real. And the change is undetectable from inside because everything inside changes together. That last clause is the one that matters, so it deserves to be stated as plainly as possible. If the rate of time changed for you, you could not tell. Not through carelessness. As a matter of structure, every instrument you would use to detect the change is made of time. Your clock is a physical process. Your heartbeat is a physical process. The oscillation of the cesium atom is a physical process. Your thoughts are physical processes. If the rate at which physical processes occur were altered, everything would be altered together, in the same proportion, and every measurement you could take would come out exactly as it did before, because you would be measuring one altered thing against another altered thing. The astronauts on the space station are aging slightly more slowly than we are. They do not feel slow. Their coffee does not take longer to cool from their perspective. Their clocks read normally. The only way anyone knows the effect is real is by comparison with a clock that stayed behind, and there is no clock that stayed behind for the Earth. There is no external reference. There is no place to stand. This is not mysticism. This is the plain consequence of the equivalence principle, and it is in every textbook. Local physics is always normal. That is the whole content of relativity in one sentence. You cannot detect your own state. You can only detect a difference between yourself and something else. So here is the question the whole account has been walking toward, and it is worth stating carefully, because the careless version is nonsense, and the careful version is not. The careless version says time is speeding up, and that is why the years feel short. That version is nonsense, and it fails for a reason you can now see clearly. If the rate of time changed globally, uniformly, for everything, then your perception would change with it, and the years would not feel short, because the feeling of the year is itself made of the same time. A uniform change is invisible by construction. It is not merely hard to detect. It is not a thing at all, in the same way that the question of whether the whole universe doubled in size last night is not a thing. The careful version is different, and it has teeth. The careful version asks about a differential, because a difference in rate between two systems is detectable. That is the only thing that is detectable. The satellite knows nothing is wrong, neither does the ground. The difference between them is measurable to 38 microseconds a day, and it is the reason the system works. So the question is not whether time is speeding up, the question is whether there are two clocks, and whether they are diverging. And the extraordinary thing, the thing that this entire account has been assembling, is that we have two clocks. We built the second one on purpose, in 1967, and we cut it loose from the first one. And the first one is the rotation of the planet, and the second one is the cesium atom, and we have been carefully measuring the difference between them ever since. We have a Babylonian clock and an atomic clock, running side by side, logged continuously, published monthly. And starting around 2020, they started diverging in a direction they had never diverged in before, at a rate roughly 100 times faster than the long-term trend, for reasons that the people who do this for a living openly describe as not fully understood. That is the actual situation. No planet is required. Nothing here needs the Anunnaki, and nothing here needs a conspiracy. Nothing in the preceding paragraph is speculative, and every number in it is published by an international scientific body and updated in public. Two clocks. Diverging, unexplained. The Sumerians would have found that entirely comprehensible. It is the exact thing they were watching for, with the exact instrument they invented for the purpose. And if you had told a Babylonian court astronomer that the sky clock and the fixed clock had begun to disagree and that nobody knew why, he would not have been confused about what you meant. He would have asked how long it had been going on, and what else had changed, and whether the price of barley had moved. He would have gone and looked at his tables. And then, quite possibly, he would have gotten frightened, because he had a word for the marker at the crossing, and a unit for the great durations, and a text that said the whole apparatus had been installed by an authority who could revise it, and a festival every spring whose entire purpose was to make sure the thing kept running. None of which makes him right. It only makes him the first person to ask. Now the other side, at full strength, because everything above is worthless if it is not put against the best available alternative. And the best available alternative is very strong indeed. There is an explanation for why time feels faster every year that requires no tablets, no gods, no core oscillations, and no divergence between clocks. It requires nothing but the ordinary architecture of a human mind. It has been tested, and it explains the data better than anything in this account has so far. It starts with a French philosopher named Paul Janet, who published the idea in 1877, which is worth noting because it means the feeling of accelerating time was already a well-recognized phenomenon a century and a half ago. In a world with no screens, no internet, no notifications, and none of the things people now blame for it. Janet's proposal is elegant enough to state in one sentence: the apparent length of a period of time is proportional to the length of your life so far. Work it out. To a 2-year-old, a single year is half of everything that has ever happened. It is 50% of the total. A 10-year-old gets 10%. At 20, it is 5%. At 50, it is 2%. And by 80, it has fallen to 1.25%. The year has not changed. The denominator has. Every year of your life is measured, unconsciously, against the accumulated total. And the total keeps growing. So each new year is a smaller and smaller fraction of the whole. And it registers as smaller because relative to your reference frame, it is smaller. The reference frame is you, and you are getting longer. This is called the proportional theory, or Janet's law. And its consequences are worth spelling out because they are genuinely unsettling on grounds that have nothing to do with Sumer. If you run the arithmetic, the halfway point of your subjective life, measured this way, is not at 40. Depending on the exact assumptions you make about when memory begins and how the scaling works, the midpoint of your perceived lifetime arrives somewhere in the vicinity of your late teens or early 20s. Half of your felt life is over before you have finished being young. Everything after that is the back half, compressing steadily, and there is nothing to be done about it, and it is a straightforward consequence of arithmetic rather than of anything mysterious. The proportional theory alone would be enough to explain the sensation, but it is not the only mechanism, and the others are better supported experimentally. The second mechanism is about memory rather than perception, and it is the one that actually accounts for the specific texture of the feeling, which is retrospective. Remember that the acceleration is not felt in the moment. It is felt when you look back. That is a clue, and the clue points at memory. Here is the mechanism. Your sense of how long a past period was is not retrieved from a stored duration, because you do not store durations. Your brain does not run a stopwatch and file the result. Instead, when you ask how long something was, you reconstruct an estimate, and the primary input to that reconstruction is how much you can remember about it. Dense memory reads as long. Sparse memory reads as short. Now consider what memory does with novelty. New experiences get encoded richly. Familiar experiences get encoded barely at all, because encoding is expensive and the brain is efficient, and there is no reason to write down a detailed record of something you have already written down 400 times. The first time you drive a new route, you remember the route. The 400th time, you arrive at your destination with no memory whatsoever of the drive. And this is so common that it has a name, and the fact that you can arrive safely with no recollection of arriving tells you exactly how little was recorded. So, childhood is dense, everything is new, every day contains multiple first times, and the encoding is heavy. And when you look back at a childhood summer, you find an enormous mass of distinct material, and the reconstruction reads it as long, because it is long, in the only unit your memory has, which is content. Adulthood is sparse. The roots are known and the job is known. The drive to work, the shape of a week, the sequence of a year, all of it is prediction rather than encounter. And the brain, doing exactly what it should, stops writing it down. A year of ordinary adult life may contain a handful of encoded events surrounded by a vast, undifferentiated field of successful prediction. And when you look back, there is nothing there, so it reads as short. Not because it was short, because it was empty of the material you used to measure length. The years are not going faster. They are getting quieter. This has a testable consequence, and the consequence has been tested, and it comes out right. And this is the thing that should give any honest person serious pause about everything else in this account. The prediction is that a period of high novelty should feel fast while you are in it and long when you look back, and a period of low novelty should feel slow while you are in it and short when you look back. Those are opposite for the two directions of estimate, which is a strong prediction because a simpler theory would have them go the same way. That is exactly what happens, and everyone has experienced it, and it is sometimes called the holiday paradox. A 2-week trip to somewhere unfamiliar goes by in a flash. You are engaged, the days are full, and you cannot believe it is over already. And then you get home, and you look back at it, and it feels enormous, like a month, like a season. The first day of that trip feels like it belongs to a different era of your life. Meanwhile, the 2 weeks before the trip, in the office, felt endless while you were living them, and have now vanished entirely, leaving no trace at all. Same 14 days. Opposite readings in both directions. And the theory predicts both, correctly, from one mechanism. Then there is the laboratory work, which is where this stops being a nice story and starts being science. The oddball effect is the cleanest of these. Show someone a rapid sequence of identical images and then slip a different one in. Ask about the duration of the odd one. It is consistently reported as longer than the repeated ones, despite being displayed for exactly the same time. It has been replicated extensively, and the size of the effect can run to 20 or 30% and occasionally higher. Novelty dilates the felt duration of the present moment. Repetition contracts it. That is a measured effect, in controlled conditions, with the physical duration held fixed by a machine. There's also the work on arousal and body temperature and stimulants, and it is old and consistent. Raise core temperature and people overestimate elapsed time. Give people stimulants and they overestimate. Give depressants and they underestimate. Whatever the internal timing mechanism is, it runs faster or slower with the metabolic state of the person carrying it, which is very hard to square with any account in which the perception of time is a direct reading of the passage of time. The neurochemistry has been narrowed down substantially. Dopamine is central. Work with animals shows that manipulating dopamine shifts timing judgments in a consistent direction, and clinical observation in Parkinson's disease, where the dopamine system degrades, shows characteristic timing distortions. There is an entire model, the striatal beat frequency model, which proposes that the brain times intervals by reading the coincidence patterns of oscillating cortical neurons through the striatum. And while the details are contested, the general picture is that timing is a constructed neural computation and not a sense. You do not have a sense of time. You have an inference about time, produced by machinery, and the machinery has known failure modes. And every one of the failure modes is in the direction that produces exactly the report you are making. And there is more. There is telescoping, which is the systematic tendency to place past events closer to the present than they actually were. Ask people when a well-known public event occurred and the estimates cluster too recent, and the error grows with the distance. Something from 12 years ago gets placed at 8, and notice what that does. If everything in your past is being pulled forward, then the intervals between things compress, and the felt density of the last decade goes up, and the decade reads as shorter than it was. Telescoping is a documented, measured, well-replicated bias, and its direct output is the sensation of a life moving faster than it is. There is the research on how the estimate depends on the question. Whitman and Lenhoff, in 2005, surveyed a large sample across a wide age range and found something important. When asked about the speed of time in general terms, older respondents did report it going faster. But when asked about specific recent intervals, the last week, the last month, the last year, the age effect largely flattened. The acceleration lives in the global judgment, not in the local ones, which is very hard to explain if time is actually accelerating, and very easy to explain if the global judgment is a reconstruction built from memory density and the local judgments are not. And there is the simplest observation of all, the one that costs nothing to check. The feeling is not new. Janet described it in 1877. Seneca complained about it. Ancient writers complained about it. If the acceleration were caused by anything specific to the modern world, by screens or pace or information density or the rotation of the Earth since 2020, then the reports should be new. They are not new. They are as old as writing, which is to say they are as old as the Sumerians, which is a fact that cuts directly against the thesis this account has been building, and it would be dishonest not to say so. So put the two accounts side by side and be fair about it. The psychological account explains the universality because every human has the same architecture. The age gradient follows because the denominator grows for everyone. It explains the retrospective character, being a theory about memory in the first place. The holiday paradox comes out in both directions from a single mechanism, which is a genuinely impressive piece of work. Janet, in 1877, and the complaints from antiquity are covered without strain. Controlled laboratory experiments with physical durations held constant support it. Its predictions have been tested and confirmed, and it requires nothing that is not already known to exist. By any standard of evidence anyone would accept in any other domain, it wins. It is not close. The rotational account explains none of that. It cannot explain why an 8-year-old and an 80-year-old report different rates while standing on the same planet. The holiday paradox is entirely outside its reach. Janet, in 1877, defeats it outright, since the rotation was doing something entirely different then. And, most damningly, the magnitude is a joke. A millisecond and a half per day is roughly 1 part in 50 million. If the day is short by 1.5 milliseconds, a year is short by about half a second. Half a second. Nobody has ever noticed half a second in a year, and no mechanism has ever been proposed by which a nervous system could. That is the honest state of the argument, and anyone who tells you the rotation explains the feeling is either not doing the arithmetic or is hoping you will not. So, why has this account spent all this time on the tablets and the core and the leap seconds. Because of a distinction that matters, and that gets destroyed the moment anyone starts shouting. The psychological account explains the feeling. It explains it completely, and it is almost certainly correct, and you should believe it. The feeling of time accelerating is your memory getting sparser as your life gets more predictable. And the remedy, incidentally, is not mysterious. Novelty, difficulty, unfamiliar places, unfamiliar problems, unfamiliar people. The thing that makes your years long is doing things you have not done. That is not a metaphor, and it is not self-help. It is the direct engineering consequence of the encoding mechanism, and it is the single most actionable piece of information in this entire account, and it is free. But explaining the feeling is not the same as explaining the anomaly, because there are two separate claims on the table, and they have been getting welded together by people who benefit from the confusion. Claim 1 is that time feels faster. That claim is true, and it is psychological, and it is solved. Claim 2 is that the rotation of the Earth began behaving in an unpredicted way around the year 2020, that it is running against a 4.5 billion year trend, that the deviation is roughly 100 times the size of the trend it is opposing, that it is very likely driven by something in the core that we have observed for less than 2 full cycles, and that the international timekeeping system is now facing the first negative leap second in its history, and nobody is confident about what that will do. Claim 2 is also true, every word of it, and it has nothing whatsoever to do with Claim 1. The dishonest move, the move that sells books, is to use the felt truth of Claim 1 as evidence for the physical reality of Claim 2, and then to use the physical reality of Claim 2 as validation for the ancient material, and then to use the ancient material to explain the feeling, which is where you started. It is a circle. It is a very well-constructed circle, and it has been running for 50 years, and it has made a lot of money. The honest move is to hold them apart, and when you hold them apart, something more interesting than the circle remains. What remains is a tablet, not a metaphor. An object, named in the texts, described in the texts, with a function, and the function is the regulation of how things run. The Sumerians called it the Dub Namtar. The Akkadians called it the Tupi Shimadi. Both phrases mean the same thing, and it is usually rendered into English as the Tablet of Destinies. Understand first what the word destiny is doing here, because the English is misleading and the misleading is important. Namtar in Sumerian, Shimtu in Akkadian, does not mean fate in the fluffy sense of a predetermined story. The root of Namtar is to cut, to decide, to determine. A destiny in this system is a decree. It is an allocation. It is what a thing has been assigned to be and to do, the way a job has a specification and a canal has a route. Every entity has a Shimtu. The Shimtu of a river is to flow, and the Shimtu of a king is to rule. For a god, it is whatever the assembly has allocated. It is not prophecy, it is configuration. And the Tablet of Destinies is where the configuration is written. It is described as an object worn on the chest, a sealed tablet, and it confers the authority of supreme kingship on whoever holds it. Not symbolically, the texts are explicit that possession is the authority. Whoever wears it holds the Enlilship, the executive power over the cosmos, and the arrangement is transferable, because the tablet is a physical object, and physical objects can change hands, which is the most extraordinary theological claim in the entire Mesopotamian corpus, and almost nobody remarks on it. The supreme power in the universe is not a being. It is a document. The gods are the administrators. The tablet is the operating system, and the gods hold power only while they hold the tablet, which means that in this cosmology, the rules are not an expression of the ruler's nature. The rules are a file, and the ruler is whoever currently has the file open. In the Enuma Elish, when Tiamat makes Chingu the general of her army, she gives him the Tablet of Destinies and fastens it to his chest. And the text says that with it his command shall not be altered, and the word of his mouth shall be fixed. Marduk defeats them both, and the first thing he does after the killing, before he builds the sky, before anything, is take the tablet off Chingu's chest and seal it and fasten it to his own. Then and only then does he begin the construction, and the construction, as established, is the calendar. He takes the file, and then he rewrites the clock. That is the sequence in the text. Acquire configuration authority, install time, and then there is the Anzu myth, which is the story that should be famous and is not. Anzu is a bird, a vast one, sometimes with a lion's head, born of the mountains and the waters. In the standard Akkadian version, Anzu is given a position of trust. He is made a doorkeeper in the sanctuary of Enlil, and being a doorkeeper, he watches Enlil. and he watches Enlil every day, and the text says that his eye kept looking at the trappings of the Enlil ship, the crown, the robe, and the tablet on the chest. He coveted the Enlil ship, in the text's own words. Then comes the moment Enlil removes his garments to bathe, and he sets the tablet aside, and Anzu, who has been waiting and who has been watching for exactly this, takes it in his talons and flies to the mountain, and the cosmos stops working. That is what the text says happens, not that Anzu becomes powerful and wages war. The immediate consequence of the theft is that the ordinances are suspended, the rites fall silent, and the divine order goes dark. What the text describes is a kind of systemic outage, a cessation of the normal running of things, because the file has left the machine, and without the file, the machine does not know what to do. The gods panic, exactly as they panicked in Atrahasis. They convene. They look for a champion. Several refuse the job, which is a nice touch, because the reason they refuse is that Anzu now holds the tablet, and holding the tablet means his command cannot be altered, which means any god who attacks him will find that his weapon simply does not work, because Anzu can decree that it does not. The tablet holder can edit the rules governing the attack. Ninurta takes it anyway. He goes to the mountain, and the fight goes exactly the way the other gods predicted. Ninurta shoots an arrow, and Anzu, holding the tablet, speaks and orders the arrow to return to its component parts, and the arrow disassembles in flight. The shaft goes back to the reed bed it was cut from. Feathers return to the birds they came off. The bowstring goes back to the sheep's gut. Ninurta is left standing in a mountain pass holding a bow that is coming apart into its constituents because his enemy has administrative rights over causation. That is a Bronze Age text describing a weapon being disassembled by a command. Whatever else you want to say about the ancient Near East, it was not short on imagination. He wins in the end, on Ea's advice, by attacking Anzu's wings with the wind so that the wing feathers fly toward Anzu instead of away, so that the command to return to your source becomes an attack and the tablet comes back, and the order is restored, and everything resumes. Set the mythology aside and look at the shape of the story, because the shape is the point. There is a set of rules governing how the universe operates. The rules exist in a specific location, in a specific object, and they are not identical with any god and not inherent in the fabric of anything. They are stored. Storage implies retrieval. Retrieval implies revision. The rules can be taken, and while they are taken, the world does not run properly. And when they are returned, it runs again. The rules are, in the plainest sense, editable. And the very first thing every holder of that tablet does, in every version of the story, is address time. Marduk takes the tablet and immediately sets up the year and the months and the phases of the moon. Anzu takes the tablet, and the immediate symptom is that the ordinances stop, the periodic observances fail, the schedule collapses. The theft of the configuration file is experienced as the failure of the calendar. That is the tablet. That is what the title of this account has been pointing at, and it is not a single artifact with a catalog number that says why your years feel short. Anyone who tells you it is lying to you. The tablet is a concept, distributed across several real texts, held in real museums. And the concept is that the rate and the ordering of things is a stored parameter under the control of an authority, that the authority has changed hands before, and that when it changes hands, the symptom that appears first, the symptom that everyone notices, is that time stops behaving. And now consider Enmeduranki, and consider what happens when you count. Enmeduranki, whose name is also given as Enmedurana and Enmendur-Ana, is the seventh king in the Sumerian king list, seated at Sippur, which is the city of Utu, the sun god, which is to say the city of the god who is the clock. The number 7 is not accidental in Mesopotamian counting, and the king list shape puts him at a hinge. Later Babylonian texts, and specifically a ritual text about the founding of the Diviners Guild, say something specific about him. They say that Shamash and Adad brought him into their assembly and seated him on a golden throne. He was shown the secrets of heaven and earth, according to those texts, and given the tablet of the gods, and taught the technique of divination by oil on water and by the inspection of the liver, and that he came back and taught it to the men of Nippur and Sippur in Babylon, and that the entire profession of the Baru, the diviner, descends from that transmission. A man ascends. He is admitted to the assembly of the gods, shown the secrets, and given a tablet. Then he returns and teaches. Now open Genesis and count to 7 from Adam. The 7th is Enoch, and Enoch is the one who does not die. The text says that Enoch walked with God, and he was not, for God took him. And the extra-biblical Enochic literature, which is enormous, says that he was taken up and shown the secrets of heaven, and shown the courses of the sun and the moon, and given the calendar, and that he came back and taught it, and that his particular expertise, the thing he is famous for in that tradition, is the reckoning of time. The astronomical Book of Enoch, which is a real text preserved in Ethiopic and attested in Aramaic fragments among the Dead Sea Scrolls, is precisely and exclusively about this. It is a treatise on the calendar. The gates of the sun are given, and the courses of the moon. It argues for a 364-day year against the lunar reckoning, and it is emphatic, and it is angry about it. And the reason it is angry is that it says the wrong calendar means the festivals fall on the wrong days, and the entire relationship between the people and the sky comes apart. The seventh man is taken up, is shown the sky, is given the numbers, and comes back with a calendar. In Sumer and in Israel, both. The mainstream reading is straightforward and is almost certainly correct. It is transmission. Israel was in Babylon. The exile is a historical fact, the cultural contact is a historical fact, and the parallels between Genesis and the Mesopotamian material are extensive and well documented and run through the flood, through the ages of the patriarchs, through the shape of the primeval history. Enoch looks like Emigeranki because the Enoch material was written by people who knew the Emigeranki material. That is not a scandal. That is how literature works. Fine. Accept it entirely. Then notice what got transmitted. Of all the things that could have crossed that cultural boundary, of all the stories and all the gods and all the rituals, the thing that survived intact, the thing that both traditions preserved as the single most important secret a human being ever received from the sky, is a set of instructions about how to count time. Not fire and not agriculture. Metallurgy, medicine, and law do not take the honor either, though they had all three, and all of which they could have credited to a heavenly source, and mostly did not. The great gift, the thing worth ascending for, the thing worth a golden throne and an assembly of gods, is the calendar. Two civilizations, in two languages, across 1,000 years, agree that the most consequential thing ever handed down from above was arithmetic about the sky. That is either the most banal fact in the world, because agricultural societies need calendars and of course they sacralize them, which is a completely adequate explanation, or these people were trying, across every text they had, in every register available to them, to tell us that the counting of time is not a convenience, that it is the thing itself. There is a difficulty running underneath everything in this account, and it is not a difficulty about interpretation. It is a difficulty about how little we have. The library of Ashurbanipal is the source of an enormous fraction of what anyone knows about Mesopotamian thought. It was the collection of the last great Assyrian king at Nineveh, across the river from what is now Mosul, and it was assembled deliberately and aggressively in the 7th century before the Common Era. Ashurbanipal was literate, which was unusual for a king, and he was proud of it, and he says so in his own inscriptions, in a tone that is frankly a little insufferable. He boasts that he can read the obscure Sumerian, that he can solve difficult mathematical problems, that he can read the inscriptions from before the flood. And he collected. He sent agents out across Babylonia with instructions to find tablets and bring them back, and where they could not buy them, they copied them, and where they could not copy them, they took them. Letters survive giving those orders. A royal acquisitions program, run by force, aimed at assembling every text in existence in one building. He got tens of thousands of tablets. The Epic of Gilgamesh, in the version everyone reads, comes from that library. The Flood tablet George Smith read comes from that library. Much of the Enuma Elish, much of the Omen literature, the medical texts, the lexical lists, the astronomical material, all of it is Nineveh. And in 612 before the Common Era, the Medes and the Babylonians came, and Nineveh fell, and the palace burned. Which is why we have it. That is the fact that never stops being strange. The single greatest deliberate act of preservation in the ancient world was preserved by being destroyed. The fire that ended the Assyrian Empire baked the clay and the collapsing ceilings buried it, and the whole thing sat in the ground for 25 centuries until Austin Henry Layard and Hormuzd Rassam dug into the mound in the 1840s and 50s and started shipping crates to London. Consider what that means about the sample. We have Ashurbanipal's library because it burned. What do we have from the libraries that did not burn? Nothing. They were clay. Unfired clay in a wet climate goes back to mud. Unfired clay that is stored properly and never suffers a catastrophe simply degrades, slowly, into the ground it came from. Every archive that was well managed, well roofed, never sacked, and gradually abandoned is gone without trace. The record we have is not a sample of Mesopotamian writing. It is a sample of Mesopotamian writing that was on fire, and the crates themselves are a second filter. Layard and Rassam were digging in the 1840s. Nobody could read the tablets yet. Cuneiform was not deciphered until the decades after, and the decipherment was a long, contested, partial process. So the excavators had no idea what they were choosing. They took what looked good. They took whole tablets over fragments. Because whole tablets look like something and fragments look like gravel. Excavation technique at the time consisted substantially of digging tunnels along walls to find reliefs. And a wall relief was worth shipping, and a broken tablet in the fill was frequently not. There is no way to know what went into the spoil heaps. Some of it certainly did. And then the crates arrived in London and went into storage. And the storage is where a great many of them still are. The number that gets quoted for the British Museum's cuneiform holdings is around 130,000 pieces. Estimates for the number that have been properly published and translated vary depending on what you count, but the honest summary is that a substantial portion have not. Not because anyone is hiding them, because reading a cuneiform tablet is slow, difficult, expert work, and the number of experts is tiny, and there is no money in it. And each tablet can take a specialist days, and there are more tablets than specialist career hours available on the planet. There has been recent progress with machine assistance, and there are projects applying pattern recognition to fragment matching and to transliteration. And they are genuinely promising, and they may change this situation within a generation. Which is a good thing and also a slightly vertiginous thing, because it means the corpus is about to get bigger, and nobody knows what is in it. So when anyone, in any direction, makes a confident claim about what the Sumerians knew, run the chain. We have the tablets that burned, from the sites that were dug, selected by men who could not read them, shipped to museums where a minority have been translated by a field of a few hundred people across 2 centuries. That is the pipeline. Every claim in this account, including the skeptical ones, comes through it. This cuts both ways, and it is important to be clear that it cuts both ways, because the people who want to believe extravagant things love the argument from the unread archive and they use it dishonestly. The unread tablets are not evidence for anything. Absence of translation is not presence of a secret. The overwhelming likelihood, based on everything we have translated, is that the untranslated material is more of the same, which is to say, receipts. Barley, sheep, beer, silver, and legal disputes about all 4. The corpus is mostly accounting because the culture was mostly accounting, and the odds that box 412 contains a treatise on orbital mechanics are approximately 0. But the correct epistemic posture in the face of a heavily filtered sample is not confidence in either direction. It is humility, and specifically it is humility about the shape of the thing. We can say with confidence what is in the material we have. We cannot say with any confidence at all that what we have is representative, because we know for a fact that it is not, because we know the selection mechanism was fire. Now, one specific thing that we do have, in quantity, and that is worth looking at directly, because it is the most alien artifact the Mesopotamians left, and the one that most resists modern reading: the omen literature. The Enuma Anu Enlil is roughly 70 tablets of celestial omens. Its structure is monotonous, and it is monotonous in an informative way. Every entry is a conditional. Something appears in the sky, and therefore something happens in the world. Should the moon be surrounded by a halo with a particular star standing inside it, then such and such follows. If Venus rises in this month on this day, then the harvest will prosper, or the king of Akkad will die, or there will be rain, or the enemy will attack. Thousands upon thousands of these. Compiled, sorted, cross-referenced, copied for centuries, consulted by professionals, acted upon by kings. The modern reading is that this is superstition, and that reading is correct, and it is also incomplete on a point worth noticing. Look at the structure again. If X in the sky, then Y in the world. That is a correlation claim. And the diaries, the nightly logs, are the data collection program that would test correlation claims. And the practice ran for 700 years. And the practitioners were fully aware that omens sometimes failed, and there is correspondence in which court astronomers hedge and qualify and offer competing readings and note that a prediction did not come off. They were running a wrong theory with something disturbingly close to right methodology. They had systematic observation, standardized recording, a corpus of hypotheses, professional practitioners, institutional continuity, and a written correspondence in which results were disputed. What they did not have was a way to reject the hypothesis. The theory was unfalsifiable, because a failed omen could always be attributed to an intervening ritual, and rituals to avert omens are a large part of the literature. The Namburbi rituals exist precisely to cancel a predicted outcome, which means the system had a built-in explanation for every failure, which means no amount of data could ever kill it, which is exactly why they could run it for 7 centuries without noticing it did not work. That is not stupidity. That is a specific, identifiable structural flaw in an otherwise sophisticated enterprise. And it is the flaw that the scientific revolution eventually fixed, not by being smarter, but by adopting the rule that a theory has to be able to lose. And it should make you uneasy, because it is the exact flaw available to any modern person assembling ancient anomalies into a pattern. If every piece of evidence that fits is confirmation, and every piece that does not fit is explained away, then you are running Enuma Anu Enlil with better graphics. The test of whether you are doing something real is whether you can state, in advance, what would change your mind. So state it. For the thesis that the length of the day is behaving anomalously, the falsification is easy and it is public. The International Earth Rotation and Reference System Service publishes the length of day data continuously. If the rotation reverts to the long-term slowing trend and the negative leap second never becomes necessary, the anomaly is over and it was a fluctuation. That is a clean test with a public data set and a defined outcome, and it will resolve within a decade whether anyone likes the answer or not. For the thesis that the felt acceleration of time is caused by anything physical, the falsification has already happened. The magnitude is 100 million times too small, and the effect appears in 1877, and it varies with the age of the observer. It is dead. It should stay dead. For the thesis that the Sumerians encoded knowledge of some physical time variation in their texts, the falsification is that no such text exists, that the Shar is adequately explained as the third position of a base 60 system, that the king list numbers are adequately explained as royal ideology, and that every specific claim made by the people who argue otherwise has been checked and has failed. That thesis is not supported, and this account has not supported it. What is left, then, after all of that? What is left is smaller than a revelation and larger than nothing, and it is this. A civilization built the instrument. They built it out of 60 for reasons of arithmetic convenience, and it worked so well that 4,000 years later, it has not been replaced and could not be replaced by the most determined rationalizers in history. Then they pointed the instrument at the sky and watched, continuously, for longer than any subsequent civilization has watched anything. Their central religious text says that the ordering of time was installed by an authority and stored in an object and could be taken and revised. Their most important annual ritual was built around the fear that it would fail. And they said, in their oldest king list, that the deep past ran on a different scale than the present, and that the scale had contracted, and they gave the contraction in units of 3,600. None of that is evidence of anything. All of it is true. And we, 4,000 years later, using their 60 and their 360, took the second away from the planet and gave it to an atom, and then found that the planet had started to disagree with the atom in a direction nobody predicted for reasons nobody can name, at a rate 100 times faster than the trend it opposes. And then we did something they would have found unthinkable. In November of 2022, in a conference hall at Versailles, the General Conference on Weights and Measures met. This is the body that governs the international system of units. It is the highest authority on measurement that exists. It convenes every 4 years, and delegations from its member states attend and vote, and what it decides becomes the definition of the units that the entire planet uses. They took up the question of the leap second, and they passed Resolution 4. The resolution says that the maximum permitted difference between UT1 and UTC will be increased, which sounds like housekeeping, and is not, because increasing the permitted difference means you stop inserting corrections. The tolerance was 9/10 of a second. The plan is to widen it to a value large enough that no insertion will be needed for a century or more, and the target date for implementing the change is 2035. In plain terms, the world's timekeeping authority voted to stop correcting the clock against the Earth. Read that again, slowly, with everything that has come before it in mind. For 4,000 years, every civilization that kept a calendar did the same thing. They observed the sky, they noticed the drift, and they intervened. The Babylonian king inserted a month. The Roman pontiffs inserted days, badly and corruptly, until Caesar had to reset the whole thing with a year of 445 days that they called the Year of Confusion. Pope Gregory deleted 10 days in 1582, so that the 4th of October was followed directly by the 15th, And there are people buried under stones with dates in that gap in countries that adopted the reform later. The English did it in 1752 and deleted 11 days. Every single one of those interventions was in the same direction, toward the sky. The rule was always that the calendar serves the sky, and when they disagree, the calendar is wrong, and the calendar gets edited. And in 2022, for the first time in the history of the species, that rule was reversed. Not by decree of a king, by a vote. Delegates in a room raised their hands, and the decision was that from now on, when the clock and the earth disagree, we will let them disagree, and the clock will be right. The reasoning is entirely sensible, and it deserves to be stated properly rather than dramatized. Leap seconds break computers. That is not a small thing. The insertion of 2012 took down major infrastructure. Financial markets, telecommunications, satellite navigation, and power grids all depend on precise synchronization. And a discontinuity is a hazard, and the hazard is real and has caused real failures. Meanwhile, the practical cost of letting UT1 and UTC drift apart is essentially nil for a very long time, because the drift accumulates at roughly a minute per century, and nobody cares if noon is a minute late in 2100. Astronomers who need the Earth's actual orientation can use UT1 directly, which they already do. The people who voted for this were engineers solving an engineering problem, and they solved it correctly. And also, considered as a civilizational act, it is one of the strangest things we have ever done, and it went almost entirely unremarked. We decided to let the calendar come off the sky, not permanently, not catastrophically. The gap will be small for centuries, and somebody will eventually deal with it, and the resolution explicitly leaves the long-term question open, which is a polite way of saying it has been handed to people who are not yet born. But the principle has been inverted, and the inversion is total. Time is now defined by an atom in a laboratory, and the rotation of the Earth has been formally demoted to an interesting astronomical quantity that some specialists track. The clock is no longer a measurement of anything outside the room. And there is a second decision coming, and it is further along than most people realize. The cesium standard is old. Optical clocks, which use transitions at optical frequencies rather than microwave, are now roughly 100 times more precise than the cesium standard that defines the second. The best of them have fractional uncertainties in the range of 1 part in 10 to the 18th or better, which means they would not gain or lose a second over the age of the universe by a wide margin. Several national laboratories are running them. The plan, which has been publicly discussed for years, is to redefine the second again on an optical transition, and the working target has been somewhere around 2030. So within a decade or so, the second will be redefined for the second time in 70 years, and the new second will be so precise that it can detect the difference in the rate of time between the floor of a laboratory and a bench a centimeter higher. Put the pieces on the table together. We are building clocks accurate to 19 decimal places. We are simultaneously cutting those clocks loose from the rotation of the planet. The planet has begun rotating along a course that was not predicted, probably because of something in the core we cannot see and have only observed for 1.5 cycles of its apparent period. And the human beings living on the surface report universally, in every language, that time feels like it is accelerating, for reasons that are almost certainly psychological. 4 facts, all true, all simultaneous, none of them caused by any of the others, as far as anyone can demonstrate. That is either a coincidence, which it very likely is, or it is the sort of pattern that a Babylonian scribe would have written down in a diary in the appropriate column next to the price of barley and left for somebody else to look at in 700 years. Now the last piece of the argument, and it is the one that cannot be resolved, and honesty requires saying that up front rather than at the end. Suppose, purely as an exercise, that something did change. Not the careless version. The careful one, suppose that the rate at which physical processes occur on and around this planet were shifting, slightly, for some reason. How would you know? You would need a reference. That is the entire problem in one word. Every measurement is a comparison. There is no such thing as measuring time in isolation. There is only comparing one process to another process. And if both processes are altered together, then the comparison returns the same number it always did. The cesium atom is not outside the system. It is here. It is in the laboratory, on the planet, in the gravitational field, moving with the Earth. If the local rate of time changed, the cesium atom's oscillation would change with it. And the count would come out to 9,192,631,770, because that is what a second is defined to be. And a second is defined as that count, so the count cannot come out wrong. It is a tautology. We define the unit as the thing, so the thing always measures 1 unit. That is not a flaw in the definition. It is what a definition is. Your heart is not outside the system. Your neurons are not outside the system. The rate of your thought is a physical process occurring in physical matter in this location. And if the rate changed, your thoughts would change with it, and your sense of how long a second feels is produced by the very machinery that would be altered. There is nowhere to stand. That is not a mystical claim. It is the equivalence principle, and it is the most thoroughly tested proposition in physics. And what it says is that local physics is always normal. You cannot detect your own state. You can only ever detect a difference. Which is why, and this is the actual reason all of this matters, the only conceivable detector is a divergence between 2 systems that are coupled to different things. And we have exactly one of those. We built it in 1967, mostly by accident, because we wanted a better standard. Without meaning to, we constructed the only differential timekeeping apparatus in the history of the species. 1 clock coupled to the atom. 1 clock coupled to the rotation of the whole planet, which is coupled to the moon and the core and the mass distribution of everything. 2 fundamentally different physical systems, both counting, and a published record of the difference between them going back to 1958. That record is the only thing we have ever had that could, in principle, notice. And it started doing something unexpected in 2020. And in 2022, we voted to stop paying attention to it. Not in those words. Nobody framed it that way, and nobody intended it that way, and the engineers who voted were solving a real problem for real reasons, and they were right to do it. The data will still be collected. The service will still publish. UT1 will still be measured by the radio telescopes, because astronomy needs it, and satellite navigation needs it, and it is not going away. But the coupling is being cut. After 2035, the difference between the clock and the sky becomes a specialist's number in a specialist's table, rather than a thing that periodically forces itself into every operating system on Earth and makes the whole world stop for 1 second and acknowledge that the planet is not keeping up. The leap second was the last surviving ritual. It was the last time the modern world did what the Babylonians did every spring. Stop. Check the sky against the calendar. Make the correction. Admit that the sky is the authority and we are not. 27 times we did it, then we voted to stop. Marduk's maintenance schedule, the recitation of the ordering, the annual reaffirmation that the fabric holds, abolished by resolution at a conference on weights and measures in a suburb of Paris, with essentially no press coverage on a Friday. They would have found that unthinkable. Not the technology. The technology would have delighted them, and any Babylonian astronomer handed a cesium fountain would have understood what it was for within an hour, and would have wanted 3. What they would have found unthinkable is the decision. Because for them, the entire point of measuring was to find the discrepancy, and the entire point of finding the discrepancy was to correct it, and the entire point of correcting it was that the correction was what kept the world running. We looked at the discrepancy, and we looked at the cost of correcting it, and we decided the discrepancy was cheaper, which is probably true. It is almost certainly true. Nobody is going to die because noon is a minute late in the 22nd century. But it is a decision about what we are willing to stop watching. And decisions about what to stop watching tend to be invisible at the time and obvious afterward. And the reason they are invisible at the time is always the same. The cost of watching is immediate, and the cost of not watching is somewhere in the future, being paid by somebody else, who will not know what he is paying for, because the record stopped. There is one more theft in the Sumerian material, and it is the most human of them, and it involves the same object type, not the Tablet of Destinies, something adjacent and stranger. The Sumerians had a word, me, pronounced roughly may. It is one of the hardest words in the language to translate, and translators have been arguing about it for a century. The usual renderings are divine decrees, or ordinances, or powers, or offices. What the word actually denotes is closer to something for which we have no single term. A me is the underlying specification of an institution, or an activity, or a condition. There is a me of kingship, and one of the priesthood, and one of truth. Others cover descent into the underworld, the art of the scribe, the craft of the carpenter, music, sexual intercourse, prostitution, the destruction of cities, falsehood, the kindling of fire, and the putting out of fire. There are said to be roughly 100 of them, and the surviving lists are partial, and the lists are startling because they are not curated. The good and the bad sit side by side without comment. Rejoicing and grief each get one. Peace has a me, and so does the plundering of cities. Whoever composed these lists was not describing virtues. They were describing everything that exists as an activity, and treating each one as a thing with a definition that can be held. And the me are portable. That is the whole point of them, and it is why they matter here. They can be given, taken, carried, and lost. Nothing here is a quality that a thing possesses. These are objects that things run on. The story is called Inanna and Enki, and it is preserved on tablets from Nippur, and it goes like this. Inanna, goddess of Uruk, wants to make her city great. Enki holds all the me at Eridu, in his temple in the abyss. Inanna goes to visit him. Enki, delighted, calls for beer. They drink. He drinks a great deal more than she does. And in the expansive generosity of a man who is very drunk and wants to impress a guest, he begins handing over the me. 7 at a time. He gives her kingship, and then the priesthood. Out come truth, and descent into the underworld, and the art of song, and the craft of the metalworker, and on, and each time she accepts them, and each time he calls for more beer. Then he wakes up. And the scene that follows is one of the funniest and most modern passages in ancient literature, because Enki wakes with a hangover in an empty temple and asks his minister where the me are. The minister tells him, Enki, sobering fast, sends the sea monsters after Inanna's boat. She has already cast off. She is running the me back to Uruk on the boat of heaven. And Enki's agents intercept her at each of 7 stopping points. And each time her minister Ninshubur fights them off, and she makes it, and the me arrive at Uruk, and the city celebrates, and the me are unloaded one by one, and named as they come ashore. The comedy is real, and the comedy is the point. Because underneath it, the story is doing exactly what the Anzu story does. The operating specifications of civilization are a set of objects. They were in one place. They are now in another place. The transfer was not a matter of merit or destiny or divine will. It happened because somebody got drunk, and somebody else did not. That is a culture telling itself that the arrangement of the world is contingent, not eternal, not necessary. Contingent, held in objects, and subject to relocation by accident. And the same culture, in the same corpus, built its greatest work of literature around a man who could not accept that. The Epic of Gilgamesh is about time. It is not about a friendship, though the friendship is the best part of it. Nor is it about a monster, though there is a monster. It is about a man who discovers that he is going to die and refuses to accept the schedule. Gilgamesh is king of Uruk, and he is insufferable, and he is 2/3 god and 1/3 man, which is an odd fraction that nobody has ever satisfactorily explained, and which the text states flatly and moves on from. The gods make Enkidu to check him. They fight, and then they become inseparable. Together they go and do heroic things, and they kill Humbaba in the cedar forest, and they kill the bull of heaven, and the gods decide that a price must be paid, and the price is Enkidu. And Enkidu dies slowly, over 12 days, in bed, cursing, frightened, describing his dreams of the underworld. There is no glory in it at all. The text spends a great deal of time on the fact that it is undignified, and that it takes a while. And Gilgamesh comes apart. The passage where he refuses to let the body be buried is one of the most brutal things in ancient literature, and its brutality is arithmetical. He sits with the corpse for 6 days and 7 nights, and he will not permit burial, and the text explains why with a specificity that is almost unbearable. He would not give him up for burial until a maggot fell out of his nose. That is when he lets go, not when grief passes, not when he accepts it, when the body makes the argument that cannot be answered, and then he runs. He goes looking for Utnapishtim, the survivor of the flood, the one man who was granted the thing Gilgamesh now wants, which is exemption. The mountains are crossed. Then comes the tunnel under the mountain where the sun travels at night, and the text tracks his progress in Dana in double hours, so that he runs through the dark, measuring the distance in units of time, which is a detail no one ever mentions, and which is enormous. He is fleeing death through a tunnel, and the tunnel is measured in hours. He crosses the waters of death with the ferryman, and he finds Utnapishtim at the ends of the earth, and he asks, and Utnapishtim tells him the truth, which is that the exemption was a one-time act of the assembly of the gods, a specific decision on a specific occasion, and that no such assembly will be convened again, and that there is no procedure for what Gilgamesh is asking. Then he sets the test. Prevail against sleep, he says, for 6 days and 7 nights. That is the test. Not a monster, not a labyrinth, not a riddle. Stay awake for a week. And it is a perfect test. And it is perfect because sleep is the daily rehearsal of death, and because the length of the test is precisely the length of Gilgamesh's vigil over Enkidu's body, And this is a text that knows exactly what it is doing. Gilgamesh sits down, and he falls asleep immediately. And Utnapishtim's wife bakes a loaf of bread each day and sets it by his head, so that when he wakes he cannot argue. 7 loaves. The first one is dry as a chip, the next like leather, the third soggy, and down the line to the last one, which is fresh, still baking, and Gilgamesh wakes and says immediately that he only dozed for a moment. And there is the row of bread in stages of decay, which is a clock, made of the only thing they had that decays on a reliable schedule. He was unconscious for a week, and he experienced it as a moment. That is in a text from the 2nd millennium before the Common Era, and it is the exact phenomenon this account opened with. A man who cannot account for the time that is past, confronted with physical evidence of its passage, insisting that it cannot have been that long. And the ancient author understood the psychology of it perfectly, and understood that the evidence has to be external because the internal sense is worthless, and understood that the appropriate emotion is horror. Gilgamesh sees the bread and he says, "What shall I do? Where shall I go? The thief has taken hold of my flesh." He gets one more chance. Utnapishtim's wife takes pity, and Utnapishtim tells him about the plant at the bottom of the sea that restores youth, and Gilgamesh ties stones to his feet and sinks and takes it and comes back up with it. He has it. The thing is in his hand. He decides, sensibly, to take it back to Uruk and test it on an old man first. And on the way home, he stops to bathe in a pool, and he sets the plant down on the bank, and a snake comes and eats it and sheds its skin and goes. That is the ending. There is no fight, and no lesson delivered by a god. Only a man sitting on the bank of a pool, having lost the thing he crossed the world for, because he put it down for a minute. And then he goes home. And the last thing the epic does, the final movement, is that Gilgamesh shows the ferryman the walls of Uruk. "Look at the brickwork," he says. "Examine the foundation terrace. Is it not baked brick of the finest quality? Did not the 7 sages lay the plans?" That is the answer the poem gives. He cannot have more time. What he can have is a thing that will outlast him, made of baked clay, which does not rot, and which will still be there when he is not. The same material as the tablets, and the same solution as writing. That is how the oldest epic in the world ends, by pointing at the only technology these people had for defeating time, which was to make a mark in clay and let it dry. And it worked. That is the part that should stop you. It actually worked. The scribe Kuaya signed the Atrahasis tablet, and we know his name 4,000 years later. Ashurbanipal boasted that he could read the writing from before the flood, and we can read his boast. Gilgamesh points at the wall and says, "Look at the brick," and the wall is gone. But the sentence in which he points at it survives. In Oxford and London and Berlin and Philadelphia, in fired clay, because a palace burned. They were right about the clay and wrong about the wall. And the whole of their civilization, every institution and every innovation, resolves down to one obsession looked at from different angles. Writing was invented so the record would not be lost. They watched the sky so the pattern would be found, and maintained the calendar so the year would not drift. Their festival was performed so the ordering would hold, and the king list compiled so the sequence would be unbroken. Guarding the tablet of destinies mattered because the configuration could be stolen. Gilgamesh crossed the ends of the earth because the schedule could not be changed. Every single one of those is the same project. They were trying to get a grip on time, all of them, for 3,000 years, with everything they had. And the instrument they built to do it, the 60 and the 360 and the SAR, is still running on your wrist right now, and it is the only part of that civilization that never stopped. There is one tablet left to put on the table, and it is the one that produces the most uncomfortable fact in the whole of ancient history, which is that we do not know what year it is. The object is catalogued K160. It is in the British Museum, and it came out of the Nineveh Library like so much else. What survives is a 7th century copy of something considerably older, and what it contains is a record of the risings and settings of Venus over a span of 21 years, during the reign of a king named Ammisaduqa, who was a great-great-grandson of Hammurabi. This is real observational astronomy. Venus appears as the morning star, then vanishes, then reappears as the evening star. And the intervals between those events are governed by the geometry of 2 planets going around the sun at different rates. The pattern repeats on a cycle of about 8 years, but not exactly. And the small imperfection in the repetition means the pattern slowly shifts, and that shift is a fingerprint. Give an astronomer a run of Venus observations tied to specific dates in a king's reign, and in principle he can compute backward and tell you exactly when that king reigned, in absolute years, anchored to nothing but celestial mechanics. That is what the Venus tablet was supposed to do for Mesopotamian chronology. It was supposed to be the anchor. Everything else in the ancient Near East floats, because the king lists and the year names give you relative sequence, this king after that king, but nothing gives you an absolute date. The Venus tablet was going to nail the whole structure to the sky, and it did not work. The reason it did not work is that the 8-year Venus cycle means the solutions repeat. There is not one date that fits the observations. There are several, spaced roughly 64 years apart, and the tablet's data is damaged and internally inconsistent in places, with some entries that no possible arrangement of Venus can produce, presumably because a scribe somewhere in 15 centuries of copying made an error and the error propagated. So the chronology of Mesopotamia splits. There is a long chronology, a middle chronology, a short chronology, and an ultra-short chronology. And they differ from one another by decades and in the extreme, by well over a century. Hammurabi's accession is placed at 1793 before the Common Era on the middle chronology, which is the one most books use, and at 1848 on the long, and at 1728 on the short, and the argument has been running since the 1920s, and it is not resolved. And specialists still choose a chronology and state which one they are using, because you have to declare your frame before you can say anything. Sit with the shape of that. The most literate civilization of the ancient world, the one that invented writing and kept records obsessively for 3,000 years, and watched the sky every night for 700, cannot be located in time by us to better than a century? Because the one document that was supposed to fix it is ambiguous. And it is ambiguous because Venus repeats, "We do not know when Hammurabi lived. His laws are known to us and we can read them." The stele stands in the Louvre, with the text carved on it and the god at the top handing him the rod and the ring. And nobody can tell you what year it happened. The people who invented the calendar are the people we cannot date. That is not mystical. It is just an information problem, and it is exactly the information problem that has been running through this entire account, which is that time only exists as a relationship between things, and if the things repeat, the relationship becomes ambiguous, and no amount of precision in the observation can fix an ambiguity that is in the geometry. Now come forward, all the way forward, and ask the question that has been sitting under this from the beginning, because there is a version of the modern situation that deserves examination on its own terms, and it has nothing to do with the rotation of the Earth. Why does it feel worse now? Because it does, and the surveys and the ordinary experience of nearly everyone agree that it does, and the psychological account explains the age gradient beautifully, but does not obviously explain why the complaint seems to have intensified. Janet described it in 1877, and Seneca complained about it, so it is not new. But the volume has gone up, and there is a reason for that. And the reason is a direct consequence of the memory mechanism established earlier, and it is not comforting. Recall how the mechanism works. Retrospective duration is reconstructed from encoded memory. Novelty drives encoding. Prediction suppresses it. A year full of new things reads as long, and a year of successful prediction reads as short, because there is nothing in it to read. Now, consider what a modern life optimizes for. Everything in the built environment of the last century has been designed to reduce surprise. That is not a criticism, it is the entire purpose of engineering. Reliability is the elimination of the unexpected. A road that surprises you is a bad road. Any supply chain that surprises you has failed. When your phone surprises you, it is broken. We have spent 200 years systematically removing variance from ordinary life, and we have succeeded so thoroughly that a modern person can go months without encountering a genuinely unpredicted event, and that is a triumph. And it is the reason we live so long, and it also means that the encoding machinery has almost nothing to write down. We optimized for predictability, and predictability is the thing that eats years. And then there is the second effect, which is subtler and worse. The recommendation feed is a novelty machine that produces no encoding. Think about what it actually does. It delivers a continuous stream of things that are superficially new, each one calibrated to be just interesting enough to hold you and not interesting enough to require anything of you. The novelty detector fires. The orienting response triggers. And then it moves on before anything can consolidate, and nothing gets written down. Because consolidation requires the thing to matter. And to matter, it has to connect to something else, and the feed is designed specifically to be disconnected, because connection would mean you stop scrolling and go think about it. So you get the physiological signature of novelty with none of the memory formation. 2 hours pass. You could not tell anyone what was in them. The 2 hours are gone and they left no residue at all, which means that when you look back, they were never there, which means the day was shorter, which means the week was shorter, which means the year was shorter. That is not a moral argument, and it is not a lecture about screens. It is the direct arithmetic consequence of the encoding mechanism. Whatever leaves no memory does not count toward the felt length of your life. It is subtracted. Time spent in a state of stimulated non-encoding is time that is deleted from the record, and the record is what you experience as having lived. The average is several hours a day. Run that over a decade. The Babylonians would have understood this in their own vocabulary immediately, and they would have said it was a theft, and they would have named the thief. That is not evidence for anything. But the description matches the phenomenon better than any modern euphemism does. And it is worth noticing that the thing which sold Sitchin 4 million copies, and the thing which drives every version of this conversation, is not really a question about a planet. It is that people are experiencing their lives being taken from them, and they cannot find the mechanism. And when a person cannot find a mechanism, that person will accept any mechanism that is offered. That is why this stuff sells. Not because people are stupid, because the feeling is real, and the feeling is correct, and something genuinely is taking their years, and the true answer is so much less satisfying than a planet. The true answer is that your life is being consumed by the successful operation of systems designed to make your life easier, and by the deliberate capture of your attention by machines built to hold it without giving you anything to keep, and that the mechanism is not hidden, and there is no one to blame, and the remedy is inconvenient. Because the remedy is the thing the mechanism tells you it is. If retrospective duration is built from encoded memory, and encoding is driven by novelty and difficulty and consequence, then the way to make your years long is to fill them with things that are new and hard and that matter. That is it. That is the whole finding. It has been tested, it follows directly from a well-supported model, and it is available to anyone at no cost. Go somewhere you have never been. Learn a thing that is genuinely difficult, so difficult that you are bad at it, and stay bad at it for a while, because the struggle is the encoding. Talk to people who disagree with you. Take routes you do not know. Do things that could fail, because the possibility of failure is what makes the brain pay attention, and attention is what gets written down. The years you remember are the years you were uncomfortable in. Everybody knows this already, from their own life, without being told. The long summer was long, because you did not know what was going to happen. The year that vanished was the year in which nothing surprised you. And that is the honest, undramatic, verified answer to the question in the title, and it does not need a single tablet. But the tablets are still there. Before the close, the honest accounting on the planet, because it has to be done properly, and because both the believers and the debunkers get it wrong in opposite directions. Nibiru, as Sitchin described it, does not exist. That has been established here at length, and it is not a close call. What happened to the idea afterward is worth a paragraph because it is a case study in how this machinery works. In the 1990s, a woman named Nancy Leader began claiming that she was in contact with beings from Zeta Reticuli and that they had warned her a rogue planet would sweep through the inner solar system and destroy civilization. She set a date. The date was 2003. The planet did not come. So the date moved, and it attached itself to the Mayan long count calendar cycle ending in December of 2012, and the two ideas fused, and for several years there was a genuine international panic, not a metaphorical panic. NASA had to run a public information operation about it. The agency's own staff reported receiving distressed correspondence, including from people asking whether they should kill their children and their pets to spare them, and from teenagers saying they were considering suicide because they did not want to be alive for it. A survey found that a non-trivial fraction of the population in several countries believed something catastrophic might occur. Books sold, documentaries aired, a major film was made, bunkers were purchased, and the 21st of December, 2012, was a Friday, and nothing whatsoever happened. And by the following Monday, almost everyone involved had quietly moved on to something else, and nobody who had been wrong was ever asked to account for it. That is the pattern, and once you have seen it, you cannot unsee it. And it is the reason the entire field deserves the contempt it receives. Take a real thing, in this case a real Akkadian word and a real Mayan calendar cycle. Attach a claim that cannot be checked, set a date, sell the product, and when the date passes, move the date and sell it again. The mechanism does not care about the content. Nibiru is interchangeable with any other empty vessel. So that is the debit column, and it is enormous, and anyone entering this territory should carry it. Now the credit column, which is smaller and is real, and which the debunkers usually skip, there may actually be an undiscovered planet in the outer solar system. This is not a fringe claim, and it has nothing to do with Sitchin. In 2016, Konstantin Batygin and Mike Brown at Caltech published an analysis of the orbits of extreme trans-Neptunian objects. the distant icy bodies far beyond Neptune. They notice that the orbits of several of them are clustered. Their perihelia point in a similar direction and their orbital planes are tilted in a similar way. And there is no obvious reason for that. Random orbits should be randomly oriented. These are not. The proposed explanation is a planet, something on the order of 5 to 10 Earth masses, on a very wide, very eccentric orbit with a semi-major axis of several hundred astronomical units, shepherding those objects gravitationally over long timescales. The orbital period would be somewhere in the range of 10 to 20,000 years. Mike Brown, incidentally, is the astronomer who found Eris, which is the discovery that killed Pluto's planetary status. He is not a man with a history of overclaiming about extra planets. He is the man who removed one. The hypothesis is contested. The clustering may be an artifact of where we happen to have pointed our telescopes, since the surveys that found these objects did not cover the sky uniformly, and a biased sample can produce apparent clustering out of nothing. That objection is taken seriously, and the argument is live. Searches are ongoing. The Vera Rubin Observatory is expected to settle it one way or the other, because it will survey the southern sky repeatedly and deeply, and if the object is there, it should turn up. But notice the shape of the situation, and notice it carefully, because it is instructive rather than vindicating. There may be a large, undetected planet in our solar system. Its existence is inferred from a subtle statistical pattern in the orbits of distant objects. Serious astronomers are looking for it. Its period would be measured in thousands of years. That is genuinely the state of play, and it is a long way from nothing. And it is also not Nibiru, and the difference is the entire lesson. Planet 9, if it exists, is far away and stays far away. Its perihelion would still be well outside the Kuiper belt. It does not come here. Nothing about its orbit crosses the inner solar system. The thing would not do anything to us, ever, at all. It is a distant shepherd, not a visitor, and its period is not 3,600 years, and there is no reason it would be, and nobody has proposed that it is. So the correct summary is uncomfortable for everybody. The specific claim was false, and the general suspicion was not unreasonable. There probably is something out there. It is nothing like what was advertised, and the man who advertised it was not right, and was not even right by accident, because his object and the candidate object share nothing but the word planet. And this is the discipline that this entire subject requires and almost never receives. Being partially correct about the existence of a category is not the same as being correct about a claim. A man who says there is a monster in the lake, and there turns out to be a large fish, is not vindicated. He was wrong, and separately, there was a fish. Which brings this back to the Shar, and to the final honest statement about it, because the Shar is the load-bearing element of everything Sitchin built, and it is worth being precise about what it is once all the weight has been taken off it. 3,600 is the third position in a base 60 positional system. That is the whole explanation, and it is sufficient, and there is no residue. 60 times 60. In a decimal system, the third position is 100, and if the Sumerians had counted in tens, then the king list would give reigns in multiples of 100, and nobody would think it meant anything, because 100 is obviously just 100. The Shar looks significant to us for exactly one reason, which is that 3,600 is not a round number in our system. It is a round number in theirs. It is their 100, the number a scribe reaches for when he wants to say a great many, in the same way an English speaker says thousands. When the king list says a king reigned for 10 Shar, the plain reading is that he reigned for a very long time, expressed in the largest convenient unit. The same way you might say a project took 100 hours when you mean it took a while. And the fact that an author took that unit and declared it an orbital period, with no argument, on the sole basis that it was a big number in an old text, tells you everything about the intellectual standards involved. The Shar is 100. That is all it ever was. And yet, here is the last thing. And it is not an argument, and it is not evidence, and it should not persuade anyone of anything. And it is included because leaving it out would be dishonest. That 100, that ordinary unexceptional base 63rd position, is what our hour is made of. 60 seconds in a minute, and 60 minutes in an hour. 60 times 60. 3,600 seconds in 1 hour. The Shar is an hour. Every hour of your life is 1 Shar of seconds. The unit that the king list uses to count the reigns of the pre-flood kings is the exact number of seconds that passes between 1 o'clock and 2 o'clock, and the reason for that is not a mystery, and not a coincidence, and not a message. It is that we inherited their arithmetic and never changed it. So of course the same number shows up in both places. It shows up because it is the same system. That is a tautology, and it explains itself completely. And it is still true that when a Babylonian scribe wanted to describe a duration beyond human comprehension, he reached for a number, and the number he reached for is now the length of an hour, and there are 24 of them in the day you are currently spending. Make of that what you like. It does not mean anything. It is just there, in the machinery, where it has been for 4,000 years. And once you have noticed it, you will notice it every time you look at a clock, and that is the only thing this account can honestly promise you. There is one serious version of the ancient astronomy argument, and it is not Sitchin, and it deserves to be heard on its own terms, because it was made by people who could not be dismissed, and because it has never been properly answered. In 1969, Giorgio de Santillana and Hertha von Dechend published a book called Hamlet's Mill. Santillana was a professor of the history of science at MIT. Von Dechend was at Frankfurt. These were not enthusiasts. Santillana had written a well-regarded book on the trial of Galileo, and was a respected figure in his field, and he wrote this one at the end of his career, which is the point in a career at which a person either goes senile or stops caring what colleagues think, and the debate about which happened here has been running ever since. The thesis is this, that there existed, in remote prehistory, before writing, a body of technical knowledge about the precession of the equinoxes, that this knowledge was encoded in myth, because myth was the only durable storage medium available to a pre-literate culture, since a story that is entertaining will be retold and a table of numbers will not, and that the myths of the world, across cultures with no contact, contain the same technical content in different costumes, and that once you learn to read the costume, the content is legible. The book is very hard to read. It is deliberately hard to read. It proceeds by accumulation, rather than by argument, piling up Norse and Finnish and Indian and Greek and Polynesian and Central American material, and the reader is meant to feel the pattern rather than be walked to a conclusion. This is either a serious methodological choice or an evasion, and reasonable people have said both. What they claim to find is a consistent set of images, a mill or a whirlpool or a churn that turns and that grinds, and that eventually breaks or is unhinged and sinks. There is a frame that comes off its bearings, and a world age that ends when the frame slips. And the argument is that the mill is the sky turning on the celestial pole, and that the breaking of the mill is precession, the slow slipping of the pole off its old star, and that the end of a world age is the movement of the equinox out of one constellation and into the next, and that the flood myths, which are everywhere, are the memory of the old pole going under the horizon. Hamlet himself, in their reading, is a late and degraded form of a much older figure, the Amlodi of Norse tradition, who owned a mill that ground out peace and plenty in the Golden Age and then ground out salt and now grinds rock and sand at the bottom of the sea, which is the maelstrom, which is the sky turning, which is the thing that came off its axis. The technical core of the claim is that certain numbers recur. 72, which is the number of years for 1 degree of precession, 2,160, which is one sign, 25,920, which is the whole cycle, 432,000, which is 120 Shar, and which appears in Berosis and in the Kali Yuga. And they find these numbers, or near versions of them, embedded in myths as counts of warriors and doors and years and companions across an implausible range of cultures. Now the objections, and they are severe. The first is the one already established. Numerology finds what it looks for. Given a target and a free hand with multiplication and selective attention, any number can be extracted from any corpus, and the fact that they found 72 in a lot of places is not surprising because 72 is a small number with many factors, and myths are full of counts. The Norse example, the 540 doors times 800 warriors, is exactly the sort of claim that looks devastating until you realize nobody counted how many multiplications they tried before that one worked. The second is that the book's method makes it unfalsifiable, and this is the fatal one. And it is the same flaw as Enuma, Anu, and Lil. Should any story about a rotating thing count as precession, and any story about a broken thing as the pole slipping, and any flood as the drowning of an age, then there is no myth that could ever fail to confirm the thesis, and a thesis that cannot fail is not a thesis. Santillana knew this objection and did not answer it, and in places seems to regard the demand for falsifiability as a failure of imagination on the part of the objector, which is precisely the move that makes a field unserious. The third is the transmission problem. If this knowledge was pre-literate and global, there has to be a mechanism, and there is no mechanism, and the book gestures at a lost common source without proposing one. That is a very large gap. The fourth is that the numbers do not actually work. Precession is 25,772 years, not 25,920. The 25,920 figure is what you get from the round classical rate of 1 degree per 72 years, which is itself a rounding. And if a pre-literate culture had actually measured precession, they would have gotten the real value, not the tidy sexagesimal one. The tidy value is the signature of arithmetic, not of observation, which means the numbers Santillana finds are not evidence of ancient measurement. They are evidence of ancient rounding, which is a completely different claim and a much duller one. So the book fails, and it fails on grounds that are not snobbery. And yet it has never quite gone away, and the reason it has never quite gone away is worth stating, because it is the same reason all of this persists. The precession is real. That is the thing. Unlike Nibiru, unlike the 12th planet, unlike every other pillar of this genre, the phenomenon at the center of Hamlet's Mill is an actual physical fact about the world. The pole does move, and the equinox does slip, and the ages do change. Thuban was the pole star, and now it is Polaris, and someday it will be Vega. And this is not a theory, it is geometry. And it happens on a timescale of thousands of years, which is exactly the timescale on which a culture could notice it if the culture kept records, and nobody would notice it if the culture did not. So, the question Santillana asked is a good question even though his answer is bad. Did anyone notice before Hipparchus? And the honest answer is that we do not know, and that we would not necessarily be able to tell, because the only civilization with records old enough to have noticed is the one whose archive we have in fragments, filtered by fire, and by Victorian excavation, and by the shortage of people who can read it. And the deepest thing in the book, the thing that survives all the objections, is not the numbers. It is the proposal about the medium. Santillana's real claim, underneath the arithmetic, is that a culture without writing that wants to preserve a fact across 1,000 years has exactly one option, which is to make the fact into a story, because stories replicate and tables do not. That claim is not mystical. It is information theory. It is obviously correct as a matter of engineering, and every oral culture that has been studied confirms it, because oral traditions do in fact carry practical technical content in narrative form, and the narrative form is why the content survives. Which means the question is not whether myths can carry technical content. They demonstrably can and do. The question is only whether these particular myths carry this particular content, and the answer, on the evidence, is that there is no reason to think so. But the shape of the argument is sound. The medium works. And somewhere in the enormous mass of ancient story, the technical content of whatever people knew before writing is sitting, encoded, in stories we can read and cannot decode, because we have no key and no way to test a proposed key, and there is no way around that problem, and there never will be. That is the honest situation, not a secret. A permanent, structural, unfixable gap between what was known and what can be recovered. The Sumerians solved it. That was the invention. That was the whole invention. They pressed a reed into clay so that the count would survive the man who made it, and that is why we can argue about them at all, and every culture that did not do that is simply gone, with everything it knew, permanently, and we will never know what was in it, which is a reason to write things down. So where does this leave you? It leaves you exactly where you started, with the same feeling and a considerably better account of it, and with one loose thread that nobody can tie off, and the honest thing to do is to lay all three out separately and let you carry them separately, because welding them together is the fraud and holding them apart is the only integrity available. The feeling is explained, fully. Your years are getting shorter because your memory is getting sparser, because your life is getting more predictable, and because retrospective duration is reconstructed from encoded content rather than retrieved from a stored clock. The denominator is growing, so each year is a smaller fraction of the total. The novelty is falling, so each year leaves less behind. Both effects push the same direction, and they compound. The mechanism is well supported. It makes correct predictions. It was described in 1877, and it costs nothing to act on. Anyone who tells you the feeling has a physical cause is either mistaken or is taking money from you. That is the answer. It is the true answer. It should be the end of the account, and for most purposes it is. The tablets are a separate matter, and what they are is not evidence. They are a record of attention. Here is what a fair reader has to concede about them. A civilization arose in a floodplain, invented writing to defeat forgetting, invented a number system for splitting grain, and then pointed that number system at the sky and never looked away for 3,000 years. They wrote that the ordering of time was installed by a decision. According to them, the specification of that ordering exists in an object, and the object has changed hands, and while it is in transit, the world does not run properly. Their oldest list says the deep past ran on a different scale and gives that scale in the largest unit they had. They built their most important annual ritual around the terror that the ordering would fail without maintenance. And they told a story, their greatest story, about a man who could not accept the schedule and who crossed the ends of the earth to have it changed and who was told, plainly, that there was no procedure for it. None of that is a measurement. All of it is a preoccupation, sustained across 3 millennia by people who were simultaneously doing quadratic equations and predicting eclipses and running an economy, which is to say by people who were not fools. You can dismiss the preoccupation as a natural consequence of farming a floodplain with a lunar calendar. That explanation is available, it is sufficient, and most careful people accept it. But it does not fully account for the intensity, and it does not account for why this particular civilization, out of all the agricultural civilizations that ever existed with all the same problems, produced the metaphysics they produced. Everyone needed a calendar. Only these people decided that the calendar was the thing the universe was made of, and that it was installed, and that it could be taken. They may have been wrong about that. They were probably wrong about that. But being the only people who ever thought it, and thinking it that hard, for that long, with that much competence in every adjacent field, is a fact about them that does not go away because their conclusion was unsupported. And then there is the loose thread, and it is the smallest of the 3, and the only one that is still moving. The thread is not the Shar. The Shar is 100. Nibiru is not the thread either, being a fairy crossing and probably Jupiter. Nor is it the king list, which is royal ideology, and nor is it the feeling, which is memory. The thread is that we have 2 clocks and they are diverging and nobody knows why. That is it. That is the entire residue, and every word of it is published, and none of it requires anything ancient at all. We built an atomic standard in 1967 and cut it loose from the planet, and in doing so, we accidentally constructed the first differential timekeeping apparatus in the history of the species. 1 clock coupled to a cesium atom, 1 clock coupled to the rotation of a planet, which is coupled to the moon, and to the oceans, and to the atmosphere, and to a molten core that we have never seen and never will, and that appears to oscillate on a cycle of roughly 70 years, of which we have observed approximately 1.5. For 50 years, those 2 clocks did what was expected. The planet fell behind, slowly, the way it has been falling behind since the moon formed, and 27 times we stopped the atom and let the planet catch up. And then, around 2020, the planet started running fast, against the 4.5 billion year trend. At roughly 100 times the magnitude of the trend it is opposing, for reasons that the people whose profession this is described in print as not fully understood. And the shortest days ever recorded have all happened in the last 6 years, and the record has been broken repeatedly, and the international timekeeping community is now planning for the first negative leap second in history. A deletion, a moment that will not exist, and nobody knows what that will do to the software that runs everything. And in 2022, we voted to stop correcting. Those are the facts. They do not add up to a conclusion. They are not evidence of a planet or a god or a conspiracy or a message, and this account has not argued that they are, and anyone who quotes this and says otherwise is misrepresenting it. What they add up to is a situation. We are living through the first period in the history of precise measurement in which the rotation of the Earth is doing something unexpected, and we are living through it at exactly the moment we decided to stop paying attention to the discrepancy, and we are living through it while feeling, all of us, that time is running out faster than it used to, for reasons that have nothing to do with it. 3 unrelated things. Simultaneous, almost certainly coincidence. The Babylonians had a procedure for that, and it is worth remembering what the procedure was, because it is the only thing in this entire account that is unambiguously good advice. They wrote it down, in 2 columns, and they did not draw a conclusion, and they did not build a theory, and they did not sell a book. They logged the sky in 1 column and the world in the other, night after night, for 700 years, and they left it for whoever came next. Their theory was wrong. Their theory was completely wrong, and the omens never worked, and the whole apparatus of divination that motivated the project was a delusion from beginning to end. But the diaries are still good. That is the part that should stop you, and it is the part that nobody says. The Babylonians ran a wrong theory with a right method, and 2,000 years later, the theory is a curiosity and the data is still being used. Modern astronomers have used the Babylonian eclipse records to constrain the long-term change in the Earth's rotation rate because those observations are the oldest, reliable data on the length of the day that exists anywhere, and there is no substitute for them, and there never will be, because you cannot go back and take an observation in 700 before the Common Era. Every model of tidal breaking, every reconstruction of how the day has lengthened over historical time, leans on those tablets. They are load-bearing. Right now, in the present tense, a man in Babylon looked at an eclipse because he thought it meant the king would die, and the king did not die, and the man was wrong about everything he believed, and he wrote it down anyway, with the date and the place and the time, and 3,000 years later we are using it to measure the rotation of the Earth. That is the whole lesson, if there is one. The theory does not survive. The record does. They understood that, at some level, which is why the very first thing they ever did with writing was refuse to forget how much grain went into the warehouse. Everything else they built, the 60 and the sky watching and the tablet of destinies and the festival and the epic, was that same instinct scaled up until it filled the universe. Do not lose the count. Whatever else happens, do not lose the count. And we are about to stop counting one particular thing, and the reason is good, and the decision is correct, and the people who made it are not villains, and there is no conspiracy, and the leap second really did break Qantas. But we are stopping. 4,000 years, and the last ritual. And we voted it out on a Friday in a suburb of Paris, and it did not make the news. So here is the end of it. Look at your clock. 60 seconds, 60 minutes, 360 degrees on the face if it has a face. 12 numbers around the edge because they counted the segments of their fingers, or because 60 divides 12 ways, or for reasons that are lost and will stay lost because they were never written down. That object on your wrist is the oldest working thing you own. It is older than your language, older than your country, older than your religion, older than the alphabet its numerals are not written in. It has survived every empire that ever tried to replace it, including the one that had a guillotine. And the men who built it were terrified. Not of death, exactly, though they were terrified of that too. They were terrified that the thing they had built to measure the world was measuring something that could be changed by an authority they could not see, and that the only warning they would ever get was that the numbers would stop lining up. So they watched, every night, for 700 years, and wrote it in 2 columns. The numbers are not lining up right now. That is a fact. It is published monthly, and the people who publish it say they do not know why. It almost certainly means nothing. It is almost certainly the core, doing something the core does, on a schedule longer than our records. But you should know that it is happening, and you should know that we are about to stop looking. And you should know that the last civilization to take this seriously left us a warning that is not a prophecy and not a message and not a secret, and that the warning is not about a planet. The warning is the procedure. Watch the thing that does not change. Watch the thing that does. Write down both. Do not conclude, and do not sell it. Above all, do not stop. They did that for 3,000 years, and they were wrong about nearly everything, and their data is still the best we have. We have been doing it for 68 years, and we just voted to quit, and the years keep getting shorter. And that part is your memory, and not the planet. And the remedy is the one thing nobody wants to hear, which is that you have to go do something difficult and unfamiliar and possibly humiliating, starting soon, because the alternative is a life that is perfectly comfortable and perfectly predictable, and that will read, when you look back at it, as almost nothing at all. Alulim ruled for 28,800 years. He did not. Obviously he did not. It is 8 Shar, which is 800s, which is a scribe saying a very long time in the only large unit he had, and the scribe was copying an exemplar he did not question, because questioning the exemplar was not his job. But a man sat in a room in Larsa, roughly 1,800 years before the Common Era, and turned a 4-sided prism on a spindle, and cut those wedges into wet clay, and he was recording a duration he could not possibly have believed and could not possibly have verified, and he did it anyway, carefully, because someone before him had done it, and because he thought that losing it would be worse than being wrong. The prism is in Oxford. You can go and look at it. It is the color of old bread, and it is chipped, and it says that in the beginning the kingship came down from heaven, and that a man ruled for 28,800 years, and that the flood swept over, and that afterward the years got shorter, and shorter, and shorter, until they were the length of ours. And it does not say why.